Hello everyone, welcome to CCIE 3.0 curriculum. Now in this series of courses, we are going to learn from basics, so from CCNA level DC up to CCI level DC. So I'm going to cover each and every thing, a small thing, big things means topics related to CCI DC, and I'll try to make sure that I will cover each and everything. Then I will give you enough tools. I will point you towards different resources so you can prepare and you can pass your CCI DC in first attempt. Now, for me, it took 2 attempts. First attempt, I got failed, but again, you know that how this failure looked like. Once you got failed, then again, you have to build that bridge from day zero. So you work hard till your examination, and with a small silly mistakes when you got failed, it's very difficult to recover from that mentality first, because almost we are going into the depression mode, because you have done your study from last 6 to 8 months, hard study every day, maybe 8 to 10 hours, and all of a sudden your result is not in your favor. Then what to do? So those things also I will tell you that how to prepare for CCI. It's like preparation. How you are going to be ready for your lab exam and you can crack in first attempt. But again, passing the exam, because it's a very difficult exam, it's one of the achievement. But if you have solid foundation, if you have good understanding about DC concepts, then obviously even in exam, if you have some tricky questions that is coming, some sections, some modules will get changed, still you know that how you can go and solve it. Okay, so first thing for your CCI exam is your knowledge in terms of that how you're doing your preparation from very small thing to the big thing. So sometimes the concept is very small, you will understand easily. Sometimes, oh, how the packet forwarding is happening inside the ACI. Although you will not get this question in the exam, but while doing the troubleshooting, you should know the packet forwarding inside ACI, how the compute UCS is working. Although you should not know each and every tab buttons inside a UCS, but you should know that how service profile template working, how you can attach or associate, deassociate, all those things. Correct? So, okay, I'm going to tell you the strategy that we are going to use to crack our CCI DC 3.0. First of all, what you can do, you can go to this blog site, giganetworkers.in. Once you come here, I enable one new tab here, CCIE. Once you are inside the CCIE, you will go to CCIE DC 3.0. Now, once you reach to CCIE DC 3.0, I'm going to create 20 videos. 20 long videos, maybe 5 to 6 to 7 hours videos, and those videos mostly will get in YouTube live or maybe in other platforms as well. Okay, now what you need to do, that while you watch those videos, create your own notes. While you're watching the video, obviously you will create you will understand the concept, right? But you want to create your notes in your notebook, in your copy, or somewhere in your laptop. Correct? So what you can do, you watch the video, parallelly you open the document as well. So here, this is the great place that where you come and you will get all the docs. So while you watch the video, again, I will add some new things here. So strategy, I'm going to create 20 long videos. Here you can see 20 video series to prepare your CCIE DC 3.0. 20 long videos for your preparation. I'm going to include each and everything related to CCIE here. Okay, now suppose if it is your day zero and you want to start your CCIE, so from where you will start, I'll come to that. But first thing, you should know your syllabus. Now if you go and check the syllabus, there are changes in the syllabus, correct? Always Cisco is changing the syllabus after every 1 year and 1.5 years. They are changing the syllabus. So now you should go and pass a DC core. That's like you can think like written type of thing. So initially it was written and lab. When I wrote my exam, so I passed the written exam, theory exam, and then 8-hour lab. So if you go and pass your CCNP instead of written, Okay, if you have your written exam, you haven't attempted to CCI lab exam, and due to pandemic, some lockdown is there, Cisco will give you credit, means you don't need to write DC core. But suppose if you don't have your written exam, it's not valid. And suppose if you don't have your DC core, so first step is that you should have your either written exam valid or DC core. So suppose if I have my DC core, then what? So you have to go and complete your DC core. Inside DC core is a long course, and again you will get it. So don't worry. I'm going to create. I'm going to create cover everything, each and everything inside DC core with lab. Okay, you have to follow those steps, you have to follow those concepts. You will be very good, strong in DC core. Once you are very good in DC core, then you are ready for the lab exam. Now, I'm not going to open these syllabus at the moment in this video, but yeah, you should be familiar about your exam, about your syllabus. So the hard task that you are going to get, you should know each and everything about that. Okay, so know your syllabus, know your target area. That's your target. You should know, you should focus. And then later on, that syllabus will break in the points as well, in the marks as well, correct? But in upcoming video. So first thing is that know your syllabus, and first of all, know your pattern, exam pattern, your syllabus, etc. So what I'm going to do here is that I'm going to break here now, and after this you will watch one 10-minute video, continuous video related to CCNP Encore. So either it's a Encore or DC core or whatever. So my agenda here is that you should know the track. Okay, so just to know the track and different areas, either in N core, DC core, or security core, etc. The format is same. You go and get familiar with respect to the format. Once you watch that 10-minute video, then again I'll come back here and I'll start from here itself. So first task is that you go and watch that 10-minute video, come back here, and then we'll continue from here, that what we are going to cover in day number 1. Okay, I'm going to walk you through the CCNP Enterprise certification, and we'll see that what are the changes that Cisco is putting from this coming Feb inside the certification. There is complete strategy change you can see inside the CCNP Enterprise. We know that Cisco certifications are always valuable. You will get much salary hike, means compared to other certifications in the market. You will get much more reputation, and they are highly valuable certifications. We have complete sort of certification, means different type of certification like associate, professional, and expert. And as per your certification, even you can negotiate with the companies in terms of salary and other aspects. So they, as per your certification, they will think that you have the right knowledge, skill. You are very skilled in the IT. You are a skilled IT professional, and then you can go and ask for the salary because you are able to take the responsibility. So that's the reason the company will pay you. Here you can see that 99% of organization use certification to make hiring decision, because these certifications are structured in a way that they are going to test your different level of skills. So for example, if you see the old certification stack that we have, means now it's 28th of Feb. So now this become old, and now in the next slide I'll show you the new that will be available from 24th of Feb. So this old certification, you can see most of the people at the moment, at this point of time, they have we have associate level certification, professional level, then the expert level, and different type of technologies are there. So for example, routing, switching, security, service provider, wireless, others. Now this has been changed in this. So now you can see that certification has been simplified But on other hand, that will become much more focused. So now this CCNA, that is the associate level certification, this is the basic for all the professionals, and then again you can go for the expert. But CCNA become basic for the professional level. Now this CCNA will serve the purpose for enterprise, service provider, data center, collaboration and security. And parallelly, you may have the expert level certifications in that particular domain. Now again, Cisco has other certification as well, and that is the DevOps, and their track is different. But you can see that 95% or maybe 90% of things relates with associate CCNA and then the professional and then the expert. Now here you can see that if you've done your CCIE, so you know that inside CCIE, you initially means before this program, you have the theory and the lab, and that is 8 hour very difficult type of exam. And there you must need a very high percentage, for example 75 to 80% of marks in all the sections to pass your CCIE. Now comparative to CCIE, CCNP exam is also very highly skilled type of things that they are going to ask you. It means they are going to check your depth knowledge inside that particular domain. Here you can see that you have the enterprise core, security core, service provider core, collaboration, data center core. So things has been grouped strategically inside different type of core. So you have one foundation, you have one core, and then you can choose the uh, expert level, or more precisely the specialist level. So you have the core. First of all, you can see that you have the CCNA, and then you have core in these, say for example, 5 domain. So you need core knowledge, and then you can go and get your CCNP, and then you can go and get your CCIE. So from your core, now you can see that you don't have written and a lab exam. Although your core, after your core, you can go and write your lab exam. Okay, so choose between 2 lab exam inside this enterprise core. And what are 2 lab exam? If I go back, you can see that you have enterprise infrastructure, you have enterprise wireless, correct? So like that you have to choose. Now if you are in the security, choose your concentration, means you do your core, choose your concentration, and then take the lab. Like that you have all the tracks. You can see that from the slide, it's very much uh, clear and what to do at what point of time. Again, here you can see that you have enterprise, security, service provider. For everything, you have core exam, and you can go and have your CCNP. Means CCNP has 2 paper. One is core and one is the concentration, or one is the focused exam, and then you can go and write the lab exam. So for example, for enterprise, you have enterprise lab related to wireless and the CCI infrastructure, where you have different things like SD-WAN and SDA. Those new things are also added. All right, so now you can see that today means, again, today is 27th or 28th. So now we are in this certification track. So 24th of February, we have enterprise core, that is mandatory, and then you can choose one. So either it's advanced routing or SD-WAN or enterprise, wireless or wireless implement. Like that, you can choose the certifications. Summary, that Cisco has tried to reduce the number of amount of certificates, and it has been focused and grouped well logically inside single technology, or inside single group. And it's still and even they have removed the CCIE written as well. So you can do your CCNP core and you can write your CCIE. You can do your CCNP core and then you can go and focus on any of the specialized exam, like say for example SD-WAN or enterprise design, etc. All right, so this is the track. Everyone has a home, everyone gains, everyone maintains their certification, everyone awarded badges. So obviously by the end of day, once you complete the track, you can see that you have different type of badges. You have a specialist, then you have CCNA, then you have CCNP, and then you have CCIE. So you can start your journey, and then you can slowly move your career from a specialist to the expert, and that's the goal. And once you complete your CCNA up to CCI in one particular domain, then you can move to the other domain. Okay, so there is a wealth of knowledge available, and if you want to gain it, if you want to become expert, go to one technology, complete it, and then move to other technology. That will be the strategy. This particular course is focused on CCNP Enterprise, and once we have one of the core topic, then we'll go and check the SD-WAN. Alternatively, we can go and check the other stuffs as well, like design, advanced routing, enterprise automation. But at this point of time, we can check CCNP Enterprise and the SD-WAN, because the combination of enterprise and SD-WAN will give you weightage. At the moment, SD-WAN is very hot in the market. It's very demanding. And if we combine like these two, core plus SD-WAN, so market value will be very good. What are the core skills you need? We'll see that we have complete syllabus. You can go and check. So now this was the past where you have route shoot, arc, and other stuffs. Now in future, now present, I better tell this. This is the present. So you have enterprise core batch. You have a specialist. Then you have the advanced routing batch, wireless batch. Means for individual exam also you will get that exam certificate, but better that will go and club. So CCNP Enterprise with any of the four, correct? All right, so now here again you can see the summary that you have. Like if you want CCNP Enterprise, you do the core and you can do the advanced, or you can do the core, you can do wireless, any of these two. You can do the core and then you can do the design. And here you can see that CCNP Enterprise, Enterprise, Enterprise. Okay, and just try to tell that how it is equivalent to CCNP RNS, CCNP Wireless, CCNP DP. So suppose if you want to do CCNP DP, you do the core and then design, and you are the DP. If you want to do CCNP in wireless, the do all these three, and then you are CCNP in wireless. If you want to do CCNP RNS, do these two, and you are CCNP RNS. If you want to be CCNP in SD-WAN, you do core and SD-WAN, and you are the CCNP in SD-WAN. All right, so this was the certification changes, and I hope that you understand that what type of changes, what certifications we have to obtain our new CCNP, and from there we can go and prepare for CCIE as well. Hi friends, we have a very important topic to discuss today, the journey from CCNA to CCIE. And I'm going to show you a few very interesting slides that the company they should use. Suppose if they do not use those strategy and those things, then they will go in fall. You will understand while watching those slides. I will clearly mention you the success story and the failure story as well. Now this is the cartoon, and this is some of the pics from the networking world. So as a networking engineer, when you start, when you are L1 or you're in the operations, then your life is like a king. Then you start digging deep into the network technology, and then finally reaching till CCI, you'll become, like this situation. And now this is in terms of hard work, but if you see in terms of money, and I have shared one of the video already, I uploaded that the salary structure of CCI in India and abroad, and you'll find that the salary is exponential. Salary will increase like anything if you become CCI. If you have 2 CCI, 3 CCI, then your demand will be good. But now things are changing actually. So if you compare the salary of CCI 5 years back, and now if you compare the salary of the engineer, or salary of other IT professionals, like someone is doing cloud, someone is doing automation, DevOps, etc., you will find that there is change. Why there is change? Because there is change in the strategy for companies as well. So try to understand the change. What change is there? Now, first of all, I always tell this thing that you should have the T-shaped skill. That means in one core area, you are the expert. No one can touch you. But in other fields also, you should have the knowledge. So what I'm telling here is that this is important, that you have CCNP level knowledge in other areas, like you are good in security, you are good in data center, you are good in routing, switching, etc. Means you are through the platform, you are good. And in one area, you have done your CCIE. So if you have one CCIE, for example, if you have CCIE in data center, you are very good in data center technologies, like how Nexus switch is working, the storage switches are working, the compute, the overall fabric, how the extension of DC, security, virtualization, those things you are very much good and comfortable. Correct. Now, uh, this is surprising, but now companies, they are looking for, or they are giving much more preference. So CCNP, I'll give him higher end, one CCIE, and that's the fact of the market today. So companies, they are looking for T-shaped, or maybe if it is not flat T, but still if it is like this type of shape. I don't know what shape is this. This is the rectangle. So rectangular type of shape knowledge they want. That means they want CCNP level of knowledge. If we have in different area, I'll write 1, 2, 3. At least in 3 different areas, you have CCNP. CCNP is like network professional. That will be greater than CCIE in one area. That's the common norm nowadays. So if you're preparing for CCIE, you do your preparation, get the certification. I have 2. You also go and do it, but in terms of job, in terms of salary, if you want quick enhancement, if you want quick salary growth, then you can easily go and do 3 CCNP. Correct? Choose your areas. First of all, routing, switching, data center, and security. These 3 core areas, if you do your CCNP, obviously you will get the attention from the from various companies. Correct. Now I'll show you the important slide. So what is happening nowadays, that you will see, and why this is very important. This is not that we are in even 2000 or maybe 2010 also. That also we can compare. So 2010, and if you check the technology in 2020, like only just 10 years span, what is happening? Now every year some technology, we have major changes. That means that you have to go and learn the new things every year. Now this frequency was 5 years. So after every 5 years, there was some major change in the technology. And this is true for software. This is true for hardware networking as well. Why? Because in network now you have software defined network. So you will see every year, or maybe every 1.5 years, you have to learn major things. You can see now in Cisco, you have to learn SD-WAN, ACI, both are SDN platform. Then DNA is coming. DNA is already, so many companies, they are using DNA, digital network architecture. Correct? So be ready. And suppose if you're looking for this type of knowledge, it's impossible, correct? That you can't have expert level. You can't make multiple T's. It's impossible. It will take 15-20 years. It's not possible, correct? It's possible, but it's difficult and it's time consuming. And the moment you're studying your CCI, preparing your CCI for 1-2 year, again major change in the industry, major change in the technology, then what you will do? So someone was preparing for routing and switching, suddenly the certification got changed to CCIE Enterprise. And in CCIE Enterprise, you have DNA, you have SD-WAN, you have so many new things. You have automation, scripting, etc. Correct? So be focused. What you are studying, you are studying, and all of sudden things will get changed. So be ready for the change. That's one key thing. And finally, talent is critical. Talent is a key. So that was the thing that I was telling earlier in my video, in the starting of my video, that companies, they are looking for talented engineers. And what's the reason? So as per the study, let me show you, the study is telling that if a company having talented people, you can see that 33% people are talented, that has more successful than a company has 29 or less than 29% of talented people. So the success story, how it is building, and again, this is from different studies and surveys, this particular chart and graph. So success story is measured. How it is measured? It is measured with 3 pillars: technology, people, and process. You should have process. Most of the companies, they have process, correct? And you can see that the successful companies, they have 26% process with compared to the companies they are failing. Again, you know, the term like micromanagement type of thing. So big company, they don't have such much of that much of micromanagement, who is doing what, who is logging at what time, etc., etc. You know, all these things. And big companies, they are giving the task, so they have the trust on the employees. They are giving the task to the employees, and they are assuming that they will complete within the time. That's the key here. So if you have talented employee, obviously they will do it. If you don't have, it will not get completed. So either it's a IT model or business model, you can see the success, and this is very, very important, the study we have. And finally, you can see that early developing and maturing. So the matured company, like from 5 or 10 years from now, they will put so much emphasis on the over the technology. Still, they will give emphasis over the people, talented employees. And then finally, you can see that process. So process will get decrease, talented people will come, they will do the collaboration. Obviously, they can use SDN, automation, scripting, all those things they will use, because you can see talented people, they are using the technology better than the those type of engineers who have less certification, or they have you know, they have somewhat less certification, they have somewhat less experience, etc. So if company is spending money to hire talented people, that is a core. So apart from technology, investment over the people is also important, and that's why all the time we are seeing that CCI people are hiring CCI, or now 3 into CCNP. For me, it's not equivalent, but again, CCI, you have golden number, CCNP you don't have. But in terms of knowledge, in terms of experience, if someone has done 3 into CCNP, then they are also as good as CCI as well, correct? Because they have diversified knowledge area. Great, guys. So I hope that you understand and you will get some gain that in which direction we should go and enhance our career. All right, so let me stop here. Thanks for watching. We are still discussing that how the job roles are changing. So suppose if someone has done the CCNA today, what he has to do under same umbrella, under same CCNA after 2-3 years. And that's the topic that we are going to discuss here. So the job role is changing, where we are standing and where we should stand. That's a very important thing that we are going to discuss, and why it's happening, changing, that we are discussing from previous videos as well. Now you can see here in the chart that what is the expectation and where we are standing at the moment. So you can see that Cisco engineers, they are leading in the network configurations. And again, this video that we are seeing here, that is related to network engineers. And that may be Cisco, Juniper, or any other vendor, but you can analyze this with respect to Cisco, and then you can apply with other vendors as well. Okay, so Cisco or other vendors, they are doing great in terms of network configuration, troubleshooting, design, and hardware deployment. And now because there is shift in a paradigm, there is shift in networking. So now we have SDN, network programming, IoT, and cybersecurity. Cybersecurity is also one key area because while we are moving inside the digitization, you have to understand the security threat nowadays with the newer framework like SDN or DNA, etc. What customers are doing, that they are directly getting exposed to the cloud, to the internet, to the public surroundings or public area. So that's very important key here, that as much as you are utilizing the online platform and data, you are exposed to public domain, and security is a threat. So you have to put tight security guideline to provide the security. And where Cisco engineers or other networking guys, they are lagging, still we are lagging in the cloud inside, because for cloud, again, you have to learn new things like AWS or Azure or Microsoft vendors and other different vendors who are the major player in the cloud. Analytics, digital innovation, and management automation. This is again one of the key area, and you will see that so many companies, so many vendors, they are creating management platform. Now management platform or orchestration platform we have in Cisco, like in DNA, you have DNA Center. For WAN, you have SD-WAN. For ACI, you have Epic Controller. So those are nothing but the management automation platform. Okay, great. Now you can see that CCNA job role. So 2018 and below, and you can think this as a range of 3 to 4 years. So I have given like 18, 19, and 20, but this is the futuristic scope of CCNA, and you can think in a realm of 3 to 4 years. So from 2020 till 2025 or 2024, what will be the expectation from CCNA engineer? They should be good in the troubleshooting, network configuration, network programming. Now these are the new areas that has been added. Programming, network configuration is something that they are doing it, but exposure is there, weightage is there more and more. So you do the network configuration with respect to programming. You write the Python program or a script, and with program you do the configuration. Or from the management platforms or the orchestration platforms, you can do the programming. That's the expectation, correct? So that is one of the key aspect that is changing. And even in terms of troubleshooting as well, from the network management platform or from the script, from the tools, you can do the troubleshooting rather than doing the CLI thing. Correct. So that one thing, and again you can add policy management as well. So policy management, network programming, troubleshooting, T-shooting, and network configuration. Now for CCNP, you can see again. So from CCNP, you can see the journey has started like management automation. So you have DNA, you have SD-WAN, you have Epic controllers, you have other management tools, you have insight tools, you have AI ops tools, different things you can go utilize for CCNP. So CCNP engineers can manage the entire infrastructure with the management automation platform or tools. Network programming. So these are going hand in hand. So you are doing the management automation with respect to APIs, with respect to tools that you have. And finally, you can see that one other key area, that project/product management. So not only that you are managing the infrastructure, you are creating the design, etc., but you are managing the project as well. You are the team lead, you have this project, you have to complete it. Now the third variant, CCIE, and you can see there a lot of change here in the CCIE. So CCIE, they are not only doing the designing and the solution architect, etc., but they should also know network programming, management automation, security management, troubleshooting, the new innovation in terms of digitization, cloud provisioning, and project management. So you can see the area for CCIE has grown a lot. It's not only that you can go and pass your CCIE exam, theory plus lab, and your life is good. You have to check the network application project life cycle. So that means that not only the network, not only the application, but the application using that network, and that is that will fall under your bucket as a project, and you have to manage that project. What are the tools you can use? You can go and use the programming tools. You can go and use the automation tool, and you have to create a security framework in a way that inside your framework. So when you're putting the framework, you are putting the network, you are putting the application, you are taking help from the programming, you are taking the help from the management automation platforms, but everything should be glued inside security. So your framework actually is security, and everything, the security plus project, and everything is going inside security and the product. So if you ask me that what I recommend, I'm going to recommend you that for CCN engineer, what should be the target area, and for CCNP and CCIE in the next slide. But as per the survey, you can see that survey is telling that cybersecurity weightage, those are critical. Those are going to be critical, 51%. And again, this is with respect to network admins or network engineers. So cybersecurity, network routing and switching, network design, virtualization, cloud, data center, and SDN. So you can have a mark at least up to this, even if you are interested in IoT and NFV network function virtualization, you can have a look. But what are the top key areas that you should look as a CCNA engineer, CCNP engineer? You can see at least 6 or 7 listed here. So for CCNA, check cybersecurity, RNS, cloud, virtualization, wireless, and SDN. Actually, this is new CCNA syllabus. So just go and follow the CCNA, new CCNA syllabus. But if you come inside CCNP, you will find so many things are there. And for CCNP, you can watch my recording, 10-minute video, that how the CCNA, CCNP certification got changed and what are the things we have inside the CCNP. But here you can see that if you are preparing for CCNP, you can go and check the cyber security section, route switch, virtualization, that will fall under CCNP data center, SDN. Now SDN is a broad term because for LAN you have DNA, for WAN you have SD-WAN, for data center you have ACI. So SDN you have here in DC as well, but data center, again, it's a big area. And then finally you have cloud, and cloud, obviously Cisco supporting cloud, but for cloud you have different big vendors as well, like Amazon, like Microsoft, etc. Still for CCNP, I will recommend that you should do CCNP first of all in core. Then you can go and check the routing stuff. You have advanced routing inside CCNP. You can go and check CCNP in SD-WAN. You can go and check CCNP in security. You can go and check CCNP in wireless, in this order. Correct? Finally, coming to CCIE, again, CCIE is assumed to have one major area where you are creating the T. So suppose if you are doing CCIE in security, so you are very good in security. If you are doing CCIE in data center, you are good in data center, like that. But you can see the order. So if you go and do CCIE in enterprise, you have to learn SDN first of all, SD-WAN, SDN, and DNA. That's the campus area network SDN. That's the DNAC. So these two things you have to learn for CCIE Enterprise. Network programming is something that whatever stream we have, we should know network programming. So automation and programming is a must. Then you can go and add these as electives, like after 2-3 years or next year and onwards, you can go and check security, cloud, data center, virtualization. So it's up to us that what is our support area where we are working in an organization. According to that also we can prepare. And if you are looking for job change, then the topmost priority should be SDN. Either it's a DNA, SD-WAN, or ACI, and then you can go and check the programming. So if you add only 2 things, SDN and plus programming in your CV, 100% you will get the call. And then again, if you add security features, cloud, virtualization, etc., those will be added advantage inside your CV. That is true with CCNP as well. If in CCNP, still I can see in the market huge demand for SD-WAN engineer, DNA engineer, ACI engineers. So if you have those things plus security plus programming, then it's well and good. Now this is the final slide. So you can see as per the market, and is the Chief Developer Officer, JDA software. He's telling that recruiting has changed from looking for experts for looking athletes, people who can flexibly shift from one job to another job and work well on team. So now company, they are not looking for the experts, although they are looking for athletes. Okay, so that means that someone who is ready to learn new things after every 1 year, or maybe after every 15-16 months, they have the win-win situation. So what is your win-win situation? Learn new thing every day. Try at least to understand what is new is coming in the market and learn it, and then try to implement in coming months. So learn every week and try to implement every month. That's the key. Okay, and you have to create a solid foundational background for upcoming technology. Correct. So that's the well said. The recruiting has changed from looking for experts. So they are not looking for CCIs, and that's a hard term, loose term, but they are not looking for 100% SMEs, but they are looking for athletes who can learn and deliver. Not only that, you completed your CCI, you have done your hard work one time, and then you are thinking that you're relaxed. Correct? It's not the case here. It's saying that you have done your hard work and you're ready to do the hard work. Learn and deliver. Learn, adapt, deliver. Like that type of model you have to work on. All right, so let's stop here. And I think you have understood that what is the requirement at this point of time in the market. Hi everyone, welcome back. So know your syllabus and know your exam format. So now we are going to know about our exam format. Again, in upcoming section, I'm going to do deep dive inside this. At the moment, I'm just going to show you that what's the change, where we are, and what type of exam format will come in the examination. So we should know about our exam format, correct? Now we know about this concentration exam. So here you can see that what you need your written, you need your qualification to write the lab exam, correct? Now for that, we have the CCDC, that is again DC core, and that you can see that CCNP, and then you can go to the lab exam. So you have your Cisco data center DC core exam with you have that certification. Now you are eligible for 8-hour difficult exam. Okay. Now what Cisco has done, because Cisco also has to change according to the strategy, according to the organization, correct? And now things have been changed quite drastically. So what I'm going to do here, I'm going to put one video that you should know about the marketplace. That video is related to marketplace, how things has been changed, where we are, and what we should study. That also very much required, because you will get the motivation out of it. If you are motivated, then you will go for all this CCIE level of examinations, correct? So we should know that how the organization is moving and why Cisco is doing changes in the certification, why behind the scene. Even for all the concepts and the knowledge that we should get or we are getting, we should know why behind that, why it is happening, why this is like this, why the traffic is going like this, why so much trouble, etc. Correct? Now, if you go and watch that video that I'm going to place after this recording, you will find that where the organization is going, actually organization is moving towards automation, software defined networking, cloud integration or cloud computing, security. These are the core areas, these are the core pillars: security, cloud, automation, and and one more thing, correct, that I told you. So now these 4 core areas that we have, correct, as a CCI engineer, our job role is also changing, correct? So as a engineer, it is expected like CCNA engineer will do CCNP work, CCNP engineer will do CCI work, and CCI engineer should do design, deployment, optimization, automation, solution architect, etc. And that's the reason you can see here that the lab that is focusing on full life cycle related to design, deploy, automation, operate, optimize. Correct? Automation. You will not escape from automation. We have to learn, understand automation. Everywhere you'll find the automation. And obviously, the CCI engineer should do the design and solution architect, all those things. Correct? So that's the key thing here. Now you can see the syllabus inside CCNP. This is actually CCNP, but we are going to focus inside DC core. Once we complete the DC core, then we'll quickly go inside CCI syllabus. Then we'll go and learn about ACI. We'll go and learn about automation. We'll go and learn about other stuffs as well. So DC core, and then directly going to the CCI data center 3.0. Okay, so that's your syllabus in high level, correct? Now the exam format, the exam that I cleared, that was also very difficult, and at that time we have diagnosed, troubleshoot, and configuration. So you should pass your diagnosed, you should pass your troubleshoot, you should pass your configuration. Correct? So it was like that in 3 categories. So first 60 minutes related to diagnose, then 2 hours related to troubleshoot, and suppose if we have your 3 hours, suppose if you complete those tasks within 3 hours, then in this 5 hour you are getting some more time. So suppose 1 hour was fixed related to diagnose, but in this 2 hours, so 2 plus 7, 2 plus 5 is 7. So in this 2 hour, you are getting some credit, time credit. So 1 hour is fixed. That means you have to complete troubleshoot and configuration 2 plus 5. That's the 7. And if you complete in for example 1 hour or 1 hour 30 minutes, so you have some plus 30 minutes or 45 minutes for your configuration. So you can focus more on configuration. Now, one good thing about CCI data center is that so many things have been changed inside GUI. Now, while you are doing the configuration with respect to CLI, it is taking much time than doing that configuration with respect to GUI thing, correct? But that doesn't mean that level of competition, level of examination has anything. Only thing is that you are saving time, but again, you have to learn the GUI way. Or this time you have automation as well. So I always tell everyone that there are 3 generations: CLI, then GUI, and then automation. With CLI, one by one you are doing the thing. With GUI, it's some sort of automation in CLI, and with automation is Script will do each and everything for us. Correct? So it's like generation is moving like this, and in automation we are generally talking about APIs and APIs call and etc. So all the SDN fabrics, they have rich API. So CLI, let me write it, CLI, and then GUI, and then API. As a network engineer, we have all these 3 tools. We should know all these 3. Now coming back to the CCI new format, you can see that here what you have to do, here you have technology core track, CCI track practical, and that will give you the CCI certification, the golden numbers, correct? So you have 2 things, and again I'm going to break this in more and more detail. You will understand, learn this more and more. But the core thing here is this about this new certification is that you have module. So for example, I have module 1 and module 2. Module 1 I have to pass, module 2 also I have to pass. This is something like your lab. But in module 1 also you have to do some sort of troubleshooting. You can see the module 1 is design and module 2 is deploy, operate, and optimize. But thing here is this, that they are connected. So they have the progressive storyline, that's a Cisco term. Okay, so what I'm telling here is this, that module 1 and module 2 we have to pass. There is nothing that if we pass module 1, fail module 2, we fail module 2, pass module 1, fail, correct? And you have to get equal proportion of marking in that. So I'm going to cover these things in detail, so do not worry. In upcoming section you will understand this more and more and more. I'll go deep inside this. Even we'll go and check some sample questions as well, that Cisco is giving some sample reference questions that also will refer. Okay, great. So here you can see that module 1 and module 2, design, deploy, operate, optimize. But one thing is not written here is automation. Remember, automation is also there. You have to learn. Okay, the automation is there, and in my videos you will get knowledge about automation as well. So Cisco, actually this is not new thing. Cisco has one cycle earlier, Cisco software cycle, where they are telling PID something OO, PIDO, plan, implement, design, operate, optimize, etc. like that. Okay, so here also you can see design. So as a CCI engineer, you should know design, solution architect, then deploy, means you can do the you should do the implementation, correct? So as a CCI engineer, you should know the deployment phase, how you can do the deployment. Once you do the deployment, you should know the operation thing, how you can use different automation to operate it, make the difficult task easy, or make the repetitive task with few automation script. Means suppose for example, to do a certain job via the manual work, it is taking one okay, I'll take 100 hours. So it is taking 100 hours. So for example, iOS upgrade, for examples, configuration management, baseline deviation management, configuration standardization, etc. Like those heavy lifting thing, that where you have to do this box by box in the older network, correct? Now here what you need to do with respect to a script, you run the script and iOS upgrade will happen. You run the script and the vulnerability assessment will done. You run the script and configuration management will happen, correct? And then obviously operate and optimize. So you do the operations, you do the optimizations. Means operations are doing, in optimization you create the script. And these cycles are, these cycles are not like a straight line. These are like, it will go here and it will come here. Again, if you have any improvement, you can go and again do the some redeployment, etc. So design, do the tight design, correct? And then deploy, operate, and optimize. That's a key here inside the CCI. Great. So what we have done actually here, just overview of the syllabus, and then the overview of the exam. Again, we are going to do deep study inside this. Now what you have to do, you have to go and watch one video I have dedicated after this, is related to change in the certification. Why we should follow this approach, why we should understand the design, deploy, operate, optimize. Why should we are looking for cloud integration, we are looking for automations, we are looking for security, etc. Okay, so go and watch that video, and after that we are going to start our video number 1 out of this 20 video nuggets or series. The video number 1, we will go and learn about the CCNA type of data center. Glad you completed all those previous videos. Now you're here, and what you can do here for day number 1 out of 20 nuggets, you can go to the blog site giganetworkers.in, go to the CCI tab, click CCI DC 3.0, and here you will get the document video list. Everything you will get, all the link you will get. So in day number 1, what I'm going to cover, you can see that day number 1, this syllabus that you are seeing, that I specifically created. Suppose if you are new in data center technology, correct, you don't know CCNP DC core, because CCNP is next level to CCNA, and you want to start from beginning. Suppose if you have only 1 or 2 years of experience, or maybe you are working in ISP, or you worked on other technologies like wires or any other, like maybe enterprise network, and then you want to learn data center technology. So this is the perfect place and video for you. All right, so what's the syllabus I'm going to cover in upcoming 4 to 5 hours? That day 0 and 1 related to CCNA. So you will go and learn about cloud characteristics and model and deployment. The syllabus is in detail, I will show you in a while. And then you will go and learn about the VMware virtualization. Remember, VMware virtualization is also very important, because we are going to learn about virtual networking as well in terms of ACI. And it's always good that you should know VMware terminologies as well. So in this, I'm going to cover about the cloud, and I'm going to cover about VMware virtualization as well. Let me quickly show you the syllabus here. So the syllabus means that video that you are going to watch. It will start with cloud. What is cloud computing? What is the physical cloud data center? Cloud characteristics, the scaling factors, the cloud shape. So it has itself having 7 different small sections. Inside that you have the videos. So let me quickly go through the sections. So you are going to learn about the cloud shapes, service models. Then you are going to learn about the cloud heights like deployment model. These are the theory, but we should know this theory behind the curtain, how the cloud is working, the service profiles and all those things, like if you have the Cisco Cloud Portal, Prime Services, etc. Again, these will not come in the exam, but you should know. This will make your fundamental, your foundation solid. Then VMware virtualization. So from section number 5 in this video, in this big video, you'll find the virtualization, what is VMware, what is server, what is virtualization, and then little bit of advanced stuffs related to virtual machine networking. So what is VM networking, what is port group, what is port group properties, what is distributed virtual switch, what is virtual switching system, etc., etc. Correct? So go complete, watch this, all these small chunks placed in a bigger video. Complete your video course, and once you complete, then we'll move to round 2. Then we'll move to day 2. Again, day by day you will get 20 days. I told you earlier that you have 20 days to complete CCNA to CCIDC 3.0. Okay, once you complete each and everything here, obviously you are ready. You are a ready product to crack your CCI exam. Okay, so in day 2, what I will cover, I will go and cover about cloud compute, networking and storage. Cloud compute, basically I'm going to cover UCS, MDS, that's related to a storage area network, and then Nexus. Okay, cloud network. In cloud networking, I'll cover Nexus. I'll not add very difficult stuffs related to ACIs and all. Okay, so please complete first of all day 1. Let's complete day 1, and then we'll move to day 2, and then we'll learn the new things inside day 2. In chapter 1, we will study about what is cloud computing, then what are the foundational things inside the cloud, what is cloud hype, the history behind this cloud computing, the common cloud characteristics, on-demand self-service, rapid elasticity polling services, etc. So one by one I'll hit all these things. Let us start with our topic, and let us talk about that what is cloud computing. Now suppose if you have to fly from India to Germany, then you will purchase the entire airlines, or what you will do? Obviously, you book a ticket inside the aircraft, and you will go from India to Germany like that. Okay, so that means what does it mean? That suppose if you want a particular compute infrastructure, or you can say if you want a particular network infrastructure. Why we need a network infrastructure? So let me break these things. Say companies, they want what? Profit. And companies, they are running over what? Applications. Now these applications need what? These applications need infrastructure, correct? They need IT support, they need infra, they need quick response between client and user. They need a spread of network from one branch to other branch, one from head office to the branches, like that. Okay, so this is that the overall goal is to increase the income, to increase the profit, but the other thing is that you have to decrease the infrastructure cost, or decrease the other cost involved in the operations, you can say. Okay, so what is the goal about cloud computing is that whenever you need that infrastructure, you take that infrastructure, whatever time frame you wanted, When you are not using that, release it. Okay, so that is the overall goal of this cloud computing, that it is something like need based computing, or it is something that once you need it, you take that. Once you don't need it, give them back. Something that whatever you are using, you are paying for that. Correct? Now, let's see the theory, what theory says. So this is not a miraculous product that will provide you all sort of solution. But yeah, with efficiently using this cloud computing, you can reduce the operational cost. You can reduce the overall cost of the organization. That is the overall goal of this. And how you can reduce this? Because this cloud have some properties. It has some inherent properties, like it can do on-demand self-service, like it can rapidly stretch the network, means you can stretch the infrastructure without needing so much approvals or without needing so much contracts. Then you can effectively use the resources. Then you have broad network access, because this cloud visibility is at the moment is everywhere in the globe. So you have that broad network access. And finally, you can measure the services. So you can measure, oh, I have taken service A, B, C, D. I'm using only B and D. So why I will pay for A and C? Correct? So those 5 things are very important with respect to cloud. And if you add all these 5 things, obviously you will reduce the cost of the operation. Correct? Now you can see here the cloud hype that in 2008 approx and 9, at that time people are thinking, oh, cloud is like something will solve everything. But once they know the reality, now you can see that it is constant at the moment, means still now people know that, okay, with cloud I have features, means I can reduce the cost, but you have to apply this in a proper direction, in a proper manner. Okay. Again, what is the traditional IT challenges? That you have low efficiency, although you have so many routers, firewall, workstations, means in terms of physical things, you have you invested lot many in the IT infrastructure, but what is the overall outcome? And believe me or not, that if you see your premises or if you see your infrastructure, you will find that the most expensive department is the IT department. Say for HR, what they need? They need paper, chair, table, that's it. Obviously they need one workstation to work, but if you see the IT infrastructure, you need database infrastructure, you need a router, you need security devices, you need high expensive servers, all these things you need. So if you compare the cost of, say, IT infrastructure with the cost of HR, finance, sales, you'll find IT department cost is very much high. So if we compare with the cost with the efficiency, is it that much efficient? Plus it has lack of agility. And again, that is due to extreme complexity. Let me show you that what is the definition of this cloud. You can refer this evolution of cloud. You can say that 1957 IBM has started this cloud. We'll see that in the upcoming lectures, and that what was the mainframe sharing and then how this cloud has been evolved. In 2006, this AWS, they really come very hard in the market, and at the moment AWS, I think they have 90% of public or hybrid cloud share at the moment. Rest all other companies, say Cisco, I think Cisco has less than 5% of share, even Microsoft has less than of 4% of share, like that. At the moment, the leading company in the cloud is the Amazon Web Services, or AWS, and they have more than 1,000 products at the moment in the market. So this is the final definition of the cloud computing. Let me explain this definition, because this definition is very compact. It is telling that cloud computing is a model, and you can write here demand-based model. So cloud computing is something called demand-based model. What it will do to enable the ubiquitous, a convenient, on-demand network access to a shared pool of configurable computing resources. Means you can share the resources. So whatever resources you have with respect to network, server, storage, application, services, that you can share. So it's a demand-based model where you can share the resources, and finally that can be rapidly provisioned and released. So both the things, you can deploy it, you can release it. So cloud is nothing but a type of IT infrastructure hosted somewhere. Because this is a shared IT infrastructure, so what is the good thing about this? That they can give this particular resource as a company A, B, and C. Say this is with respect to cloud, we can think like this. Now a particular client A can deploy their services, and then it can release in no time or in very less time. So that is the overall definition of the cloud computing. Let me stop here. I hope you can understand what is the cloud computing. What is the data center? When we are talking about the cloud, so suppose this is the cloud from where we are taking the resources, and once we use that resource, after that we can undeploy it. Okay, something you can say that demand based type of thing. But inside the cloud, obviously you have some sort of infrastructure, and obviously that you can think this as a data center. Now inside that particular infrastructure, they can use any form of virtualization, automation, you can say the software defined network, etc. But still they need some hardware, say related to network, related to the storage, related to say virtualization. So whatever things will be there, they need some hardware. Here you can see the model or the abstract of a data center, where you can see that we have various components. So first of all, you have the floor, and if you ever went inside the data center, you know that they have some raised floor. It depends that inside that also they can keep the UCS or power backups, or they have somewhere in the corner they can put the power backup, primary and secondary power supply. Then obviously you have a very strict entrance room. You need different type of access level to enter the room, because inside the data center you have so many devices and they are running 24/7 by 365 into say 10 or 20 or 15 years. So at that for those purposes you need proper cooling system. Okay, so this is the overall model of a data center, and if you see what is the definition of data center, it says special facility conceived to house, manage and support critical compute resources. We know about these critical compute resources. They are something called say network, storage, servers, application, etc. So to put all these critical resources, compute resources, you need a particular area or a particular data center. So that is termed as a data center. Okay, and obviously for cloud also we need a data center. Now here are some definitions about the power backup system. You can take a reference from this particular slide. What about the entrance room, telecommunication room, cooling system? Obviously you need a good cooling or AC system to cool all the devices all the time. Then we have rakes. Generally 42U rake is the standard, but it depends that what type of device, what type of port density you have. According to that you need rakes or patch panels or cabling, all sort of infrastructure you need. Finally you can see here the raised floor. Okay, so just hold on, check the definitions, and we are very much good for this particular section. What are the common cloud characteristics? And these are the common cloud characteristics. Now these things are also true for the IT infrastructure as well, but everything that we are doing here, we can think this with respect to cloud. So whatever IT infrastructure we want to elaborate or we want to work on, we can think this as these type of things inside the cloud. Okay, so cloud characteristics are that they can provide on-demand self-service. We'll see that in this particular course. Rapid elasticity, resource pooling, measured service, broad network access. Now, these things can true with the your IT infrastructure as well. Okay, remember these things. So whatever we are studying about the cloud means how we can send the resource request to the cloud, and once we get all those resources, then after that how we can undeploy it or we can cancel this. That is different thing. Okay, means that is how a user interact with the cloud, but inside the cloud or inside your premises you can use these technologies. Okay, so let us discuss more about say on-demand self-service, and we can compare this with my infrastructure and the cloud infrastructure. So suppose if you want some sort of services in your infrastructure, what are the restriction? You have to go for your technical team. Then that technical team, they will check with the contracts. Do you have contact with the third party or the ISP? If there is provisioning inside that contract, you will get the resource, but again the IT team has to deploy say in terms of servers, storage, networking, and then the user will get it. So here we have the complete life cycle inside our infrastructure. But now when we are talking about the cloud, inside the cloud how they will provide doesn't matter. But the thing is that I need that resource. Could you please deploy it? The cloud will reply, yes, you have your server, your storage, your networking. You can get it. Okay, so here you can understand the way or the approach that how we are sending the request, how we are getting the request. That is different thing. But how the infrastructure built inside the cloud is different thing. Okay, so please do not compare these things, otherwise generally people has some a misconcept, or they think, oh, what is cloud, then what is my infrastructure, like these type of feelings will come. Then rapid elasticity, suppose if you have to expand your branch. For example, you have one branch, other branch just you want for testing purpose. You have started your business in some new branch, you want to check the capabilities. Again, it will go inside a life cycle. Means you need the resources, you need say server, storage, compute, services, applications, all sort of stuffs you need. You need complete project life cycle. That is the rigidity in the IT. But in terms of say cloud, you can send one request, you have all those things. You have your server, storage, network, application, everything you will get within fraction of say hours, not second, but yeah, minutes. Okay, so that is the use of the consumption model. You want it, you'll get it. Okay, in this section, finally, let us discuss about the resource pooling. Now, again and again, I am telling you that this can be your infrastructure as well. Okay, means you are using the resources properly or not. Means sometimes what happen that say for a company I have dedicated resource. So one of the branch, say I'll take this as a branch, here it is written as a company. So one of the branch in say Arizona, I have dedicated say server, storage, networking device. Say one branch in Phoenix, for that also I have dedicated server, storage and network. That is the common practice in the traditional network. But when we are talking about the resource pooling, that means you have your infrastructure somewhere. This can be cloud, this can be yours. And inside this infrastructure, add as per need basis. So generally in modern days, now we have something called tenant for the organization. So I have one tenant, that is nothing but a logical representation of say organization or group of things you can say, or some sort of elements. Okay, so tenant 1 I have, tenant 2 I have, according to what fabric access or what level of access tenant 1 and 2 has, they will get it. So they will get virtual server, virtual storage, virtual network, virtual server, storage, and virtual network. Means this is abstracted from the actual hardware that I have here in the resource pool. Now according to the need, I have these virtual devices, and I can work on. And that is that inside the cloud they are working. So inside the cloud they will provide you all those things, but they are doing the resource pooling. So that's why according to the signed agreement from the consumer to the cloud provider, they are providing different say compute with respect to different clients. Let us discuss rest of the characteristics. We have measured services. Now what does it mean by measured service? It's actually very easy. Now suppose you have this cloud and you have purchased service say A, B and C, but you don't have any mechanism that how much percentage of A, B and C you have used inside the cloud. You must measure those services that you have purchased from the cloud. Until unless, how could you pay them correctly? Say after 3 months you come to know that C is underutilized, or maybe B is, for example, overutilized. Then how could be the billing cycle? Maybe you think that, oh, the service C I haven't used, but still I am paying. So that means we need a proper measured service for the cloud services. Now what is the problem with these type of measured services? That do you have proper visibility of the network or not? That is the key concept here. So if you have proper visibility, if you have proper monitoring tools, then only you can measure all the services or measure the applications or services that you have hosted over the cloud. Here in this diagram you can see that say I have services over one time frame, it is something like 30% used, it is something like 25% used, but in other time slot it is say more than 100 or maybe 100% used. If I have measured services, if I have visibility tools, monitoring tools, then I can set some common principle or rules. Okay, this much for this much time frame I need to utilize. Okay, now the other characteristic, this is the last one, is the broad network access, and this is again very important cloud service we have. These cloud providers, say for example AWS, they have their visibility across the globe. They may have, I think, more than 21 presence across the globe, but you need to check the sheet. But yeah, if you have the broader network access, that means the end user, they also have the visibility. So suppose if they want to use some services, this is company called ABC. It is situated somewhere in the India, but it has server in USA. So if this cloud has visibility inside India, obviously first it will go to India and then it will get that service or applications, whatever it is looking for. Now suppose if you don't have visibility in India, what will happen? You will go search the USA server and then you will come back from there. Now doing this, what will happen, you know? Doing this, you can drastically increase the latency and jitter and all those stuffs, that delay stuffs, because now your packet will go via more number of hops inside the cloud to reach to the USA server. Okay, so if you have clustering in terms of servers, if you have primary, secondary, backup servers or data centers, say one is in US, one is in India, so whatever the nearest say branch or nearest head office or nearest consumer is there, they will request to the nearest resources and they will get the response. In that way, the latency and the jitter and all those delay counters can be minimized inside the cloud. Okay, so that is one of the common principle of the cloud computing, that they have broad access or not. Okay, then let us discuss about the multi-tenancy, because So many times we are very confused about, okay, tenancy and multi-tenancy. What is actual use of tenancy, multi-tenancy? Why it is very important at the moment, say in the software defined network and in the cloud computing? Actually it is important. Why? First of all, let us understand what does it mean by tenant. So if I am telling tenant, what does it mean? So tenant is nothing but a logical entity that can represent, say, a group. So group of organization it can represent, or it can represent a department, say HR or sales or any other department, or it can be any logical entity. Okay, so tenant is nothing but abstraction over physical layer. So whatever physical fabric access you have, so you have something, say access layer where you have your physical resources, and you can add fabric as well. So you have a stretchable access layer. On the top of that you can create logical containers. Those logical containers can represent a group of organization or department, etc. That is one tenant. Now suppose I am inside one organization, says this is my organization name is say A, and for HR, sales and IT, so H for HR as a sales, and then IT, I have 3 tenant. Likewise, somewhere in some other company called B, they have their tenants like HR, sales and IT, and suppose somewhere down the line again some third company C, they also have their tenant HR, sales and IT. That is with respect to the companies. Now all these companies, they request some resources from the cloud. Okay, now because cloud, now in this cloud they have the slice, or they have a tenant, say for A, they have tenant for B, they have tenant for C. So from tenant A they can serve a company A which has their own tenant called sales, HR, sales and IT. Like B will serve B where they have their own tenant like HR, sales and IT, and C as in. Okay, so you have the tenant concept not only in the cloud, but you have inside the organization as well, and that's why it is a multi-tenant concept, and it's a very important concept. Okay, finally in this particular recording I have to cover this classifying the clouds. We'll learn more about classifying the clouds in the upcoming sessions. We have 2 criteria. One is the service model, one is the deployment model. In service model we have infrastructure as a service, that is IaaS, platform as a service, that is PaaS, and then software as a service, that is SaaS. We'll see that. What does it mean and what are the practical examples of that. Then inside deployment model we have public, private, community or hybrid clouds. And it's very important. There are some plus and minus of public, there are some plus minus of private, there are some good and some cost effective things with hybrid as well. Okay, so let us stop here. This is the last topic in this particular section. Around the corner, Agile, Cloud Scale, Application and DevOps. This is nothing but, you can say, the waterfall model that we studied in our say engineering career or maybe in BCA. We have this particular model where we start, say, with analyze, plan, design, build, test, operation. Inside operation again we have that the same life cycle. So whenever a particular project is go on live, before that what are the things that we are doing? So what we are doing, we are going to the customer premises, we are analyzing their requirement. According to their requirement, what will be the IT infrastructure we needed, means how much applications they have, how much storage they need, what is the network services, all sort of things, and plus by the end of the day, what is the uptime and what is the service, what you can say that what is the operational things they are looking for. Operational things means what type of service level agreement I have with them, in terms of suppose if some network down is there, or other stuff. So let me make this easy. So service level agreement is nothing but according to priority or severity, say P1 to P4, how our technical team will react to those things once it will come into the operation. Okay, but before that, obviously we need to analyze, we need to plan and design. This will take so many things while we'll design, then how to build, and all these models should be recursive in nature. That means that, say, once you design, it doesn't mean that again you will not come back and redesign. So if any requirement is there, or maybe say if you have design failure, then you have to come back and then again you have to plan and design and then build and test and then operate. So these life cycles are iterative, means it will go and it will come back, it will go and it will come back. Let me show you this particular process. So here you can see that inside the project timeline, once I start with analyze and plan, you can see design, build, test. This is cyclic, means once you design, build, test, again you have to design, build, test. Means if you have any flaws or if any other requirement come during the design phase or during the build or test phase, you need to change that. Once you change, again it will go into the cycle. Okay, then second, you can see that customer turnover. Now suppose you had designed a network, but due to some reason customer network has expanded. Again you need all those things like you again have to go inside the life cycle, analyze, plan, design, build, test, build, test, and then operate according to the given SLA parameters. Then if there is some technology upgradation or innovation, so suppose Cisco from Nexus 7K they move to Nexus 9K, or some other automation or SDN product they introduce into the market, then your design should adhere those changes. Means your design should be in a such a fashion that they can accommodate the customer turnover or customer requirement, they can accommodate the technology innovations as well. Okay, these things are the requirements. Here we can just stop the recording or pause the recording, not just stop, pause the recording, and you can just check that what is the phases and what are the definitions for analyze, plan, design, build, test, and operate. Okay, now again, so finally we come to a point in a conclusion that your design or your phases are in such a way that they can accommodate customer requirement as and when if it is changing. My design should be like that, that again it can do the implement and operate, correct? So what is the requirement here? It's very important to understand. That's why this Cisco devices, they are trending in the market, because these devices has a huge capability. Even if you see a normal Cisco Catalyst switch, it can do n number of tasks. Okay, so that means that devices are capable enough that if you expand the network, it can expand. Now for example, when it is coming to technology innovation, say Cisco has iOS XE in some of the routers. This iOS XE it's itself a big platform that suppose if there is technology innovation, it can accommodate all those innovations inside it. Okay, now we are discussing this with respect to cloud. Now where all these things will fit inside the cloud? Remember I told you inside cloud also you have the data center. Okay, and these rules, these principles can apply inside the data center of a particular cloud as well, and even they are using the same type of waterfall model inside the cloud as well. Hi everyone, welcome to chapter number 2. In this particular chapter, we'll learn about, say, service provider, what is service level agreement, cloud providers. We have various examples of cloud, say infrastructure as a service or platform as a service or say software as a service. So these type of cloud applications or these type of infrastructure within the cloud for our premises we can use. How we can use all these things we'll learn in this particular chapter number 2 or in this particular section. So let us start with first thing, that is the service provider and information technology. Now when it is coming to service provider, if you see your organization, you will find n number of service provider, n number of vendors from where we are taking all these services. Now these vendors including say from a toilet paper to something like we are getting some sort of telecommunication service provider or network service provider. Means for each and everything inside our premises we used to take services, and for that we have vendors. So if you see here in this particular example, you'll find that okay, for telecommunications, I have telecommunication providers such as AT&T, Verizon. Say for storage we have some providers something like EMC or NetApp. For computer service provider we may have Dell or HP or HCL. For that we have internet service provider. So whatever local internet service provider in that area, even we can include say AT&T or some other service provider vendors as well in this. Then we have primary and secondary data center service provider. Good example may be IBM or HCL or any other big companies who are supporting the compute environment within the infrastructure. Managed service, again we can think this as a say entity or maybe IBM or HCL, Wipro. They're providing this managed service infrastructure or maybe remote service infrastructure. So what is happening generally, the big companies they run their application, and for operation or you can say the operational things they are giving that services to some third party. Okay, so that third party will manage all those network infrastructure, all those say storage infrastructure, everything. So this will be the one layer before they meet to the actual vendor. So what is happening, let me draw here in the layered approach. So suppose this is the organization. Now once this organization has deployed the services for different services, they hired say managed service enterprise network. So they have some contact with say MSEN and they acquire that service. Now what happens if any problem with this organization, directly MSEN team, that service provider who is managing the services, they are interacting. Now if they are capable enough to resolve the problem, it's okay. Otherwise if they are not, then they are opening a tag case or vendor specific case, say with Cisco. Say for a storage they will open with NetApp. Say for compute, if I have some IBM vendor, they can open a case with IBM. So for networking Cisco, for storage some other vendor, for data center they have some other vendors like that. Okay, here you can check the details about all these vendors. So what you can do, you can just pause the recording and you can read through all these things, and you'll find it very much familiar because in day-to-day say infrastructure life we are finding all these terms. Okay, so let me stop here, and in the next section we'll discuss about the service level agreement. Next we have service level agreement. Service level agreement is nothing but agreement between you and service provider upon some certain criteria. So what are those criteria? Those criteria are say performance, uptime, MTTR, that is mean time to recover, and customer data handling. What does it mean by performance? Performance is nothing but the number of operation that service provider must guarantee in a time interval. That is very important. In a time interval with the offered capacity, these two things are very important when we are talking about the performance. So performance is nothing but the operation with respect to time interval and capacity. Okay. Next is the uptime. Generally we are talking that my ISP has uptime say 99.99% or maybe 999 or 59. So uptime is nothing but the it's a measure of the amount of time IT system must work correctly. So how long your IT systems are working properly, that is the uptime. So suppose if some of the services are hosted to the service provider, so how long that can be hosted. There should very minimum downtime, or if you want a good uptime, you may have primary and backup data center or primary or backup systems. Okay. Then third we have MTTR, mean time to recover. That what is the time frame in that particular system, that particular failed system will recover. That is meant by the mean time to recover. Finally, customer data handling. This is again very important because there should be some rule or there should be some strategy upon which the service provider they will provide the agreement in terms of data confidentiality and backup. So your CIA, confidentiality, integrity, authenticity should be maintained, and obviously your deletion policies or your data privacy, all these things will be maintained. Okay, so these are the key terms for a SLA: performance, uptime, MTTR, and customer data handling. Next in this we have the cloud provider. So we have already discussed that if you are asking or if you are raising some request from the cloud, inside the cloud you have different services offered. So we have a storage. Obviously we know that the storage is something related to say a storage area network or a storage where client can store their database inside the server, or whenever we have generally we are telling this server to a storage communication. So whenever you have server to a storage communication, your servers can save the data, and generally what servers saving the data in their storage, those are the client request information or client information. So client information, first it is saved inside server and then it can be replicated inside your storage, or your storage has the saving capabilities inside the storage. Both things can work. It depends upon what type of storage you have in your infrastructure. But when we are talking about the cloud, so directly from server I can store my data inside the cloud storage. Then obviously we have networking. They are doing the networking task. Later in this course we'll learn about say CSR or some virtual routers. On that we'll see that how they can do this networking over these virtual routers or over these virtual devices. Then they can provide the desktop services, the streaming, some audio and video capabilities. They will provide some web services. They can host applications, they can provide application services, they can provide database services. Now these three things are quite new here: the collaboration tools, publishing, and the middleware. So let me show you the definition of all these three. Here in this particular PPT you will get the definitions of all these. So when we are talking about the middleware, it's a supplementary software including libraries, programming language, interpreters, database services, user authentication service, account management, and so forth. Okay, so it's in the middle which is providing the libraries and binaries for different applications. Then coming to collaboration, as the name suggests, collaboration is nothing but collective effort, you can say, or the joint work from different people. One of the good example is SharePoint. Microsoft SharePoint is one of the collaboration tool. where different people can work and share their Excel or Word or other documents inside the SharePoint. Then the publishing, application that facilitate the publication of text such as blog. So blog is one of the example. Even companies, they have their own publishing tool, and they have their own actually customized publishing tool, collaboration tools, all they are using in one. Say some of the companies, they are using Yammer as a publishing tool. So different members in a team, they can create their Yammer group, and they can publish their, say, videos, audios, writing notes, all these things. Okay, and then finally we have streaming, that is, again, I already told you, that is the audio video features and the capabilities. So we are very good. Let's stop here. Let us talk about infrastructure as a service, or IaaS. You can use this pizza as a service as an analogy, that in the traditional network, what you have in the IaaS, what you have in platform as a service, what you have in software as a service, what you have. But in coming 2 to 3 lectures, we'll discuss more about all these analogy. Let us start with infrastructure as a service. As you can see here, that this blue one is the provider responsibility. So what the provider will provide you? Provider will provide you virtualization, server, storage, networking, and you can think like this. Okay, you have virtual server, you have virtual storage, you have virtual network, but you are not bothered about what that particular service provider is providing to you. Then what is your responsibility? Your responsibility is to run the application over your operating system, over your infrastructure software. Okay, so here you can see that some portions the service provider is providing, and basically these are the compute thing like server, storage, and network. And for things related to, say, operating system and the application, you are responsible. One of the major player in this particular domain is, everyone knows that is the Amazon, and AWS is the one of the major player in this. You can see here in the Gartner quadrant that AWS is leading, although Microsoft is also following up AWS, but the market share is too high of AWS with respect to any other vendors. Now, if we talk about this AWS, initially we have talked about the broad network access or network capability. You can see here that AWS, they have visibility across the globe, and this in AWS term, you can see here that they have regions and they have zones. So inside region they have zone 1 and zone 2, like that. This zone you can think as a data center. So suppose I'm talking about a particular region, say US region. Suppose in US region I have, for example, zone 1 and zone 2. That means in US region I have 2 data center. One can work as a primary, one can work as a secondary. Suppose if the customer is here, say this is the customer, and it's near to, say, India, then it will not go to any Europe or US server for their fulfillment, because in doing that, its latency, jitter, delay, everything will increase. So if it is near to India, it will query to Indian server and it will get the response. Okay, so that's why we need some sort of global availability, or in cloud term, that is the broad network access. Now AWS, if you do the AWS course, you'll find that they have more than 1,000 services or applications offered inside the cloud, and these are the, you can say, the number of services they are providing. But inside, say, game development, again you will get some sort of applications and things. Okay, so let me show you quickly in this particular slide that what are the main services they are offering. So they are offering services related to storage, and let me start from the beginning. So first of all, they have something called AWS Global Infrastructure. On the top of that, we have all the services. So on the top of that, we have compute, database, mobile services, management tools for the visibility. They have messaging tools, developer tools, security storage, blah blah blah, all type of things. The new things they have added: artificial intelligence, Internet of Things. At the moment, in present, this artificial intelligence is trending very high, and you can think that next IT market in coming say 3 to 10 years is purely inside artificial intelligence. And at the moment, this Internet of Things is also peaking very high. So we have current business or marketed for Internet of Things as well. So these are the IT, these are the technology where IT is trending at the moment. Okay, so inside these all these things, say if we are talking about compute, you can see here inside compute we have services like EC2 container service, lightest all, number of services you'll find. Say inside storage we have simple storage solution like S3, then elastic file system, Glacier, storage gateway. In database we have relational database management. Say in networking and content delivery we have virtual private cloud, CloudFront, Route 53. So all sorts of applications we have inside AWS. Here I have listed few of the services and the definition. You can have a look on that. Say EC2. So what EC2 will provide? EC2 will provide you cloud service that provide virtual services that are fully controlled by AWS user, resized according to requirement of compute demand. Because obviously this is what? Compute. EC2 is elastic compute. Okay, and it offers all sort of operating systems. EC2 enables robustness through the regions and the availability zone. So remember, we have the region, we have the availability zone. You can correlate with the data center. Okay, and then they are providing security things related to cloud, and that is interacting with the customer, such as VPN and other security protocol supported. Then we have the storage. So if you want to remember all these things, because there are quite a bit in number, so you can think like to run a data center, what you need? You need network, you need a storage solution, you need management for visibility, so you need management tool, you need, obviously you need compute, but you need compute with respect to all of these. Obviously you need security. So with respect to all these things, you will find the applications inside AWS. So some of the applications are related to storage, S3, EBS, EFS. Some of them are related to networking, that is the virtual private cloud. It is actually for networking, because generally this AWS, you can term AWS as a public cloud, but inside that public cloud you can mix with your private infrastructure. So at that time this term, this will make AWS as a private cloud. Later we'll learn about the features of public and private cloud, then it will become easier to you to understand. There are some other features as well, like direct connect. Suppose if you want direct tunnel from yours to the AWS, with this feature you can have that. Then we have elastic load balancing. We know what is the importance of load balancing. Even we have one dedicated chapter for load balancing. We'll see that how load balancing supporting the balancing between the user request and the available servers inside the data center. And then finally we have route 53. So this 53 is nothing but DNS port number. So from there they have derived this route 53, and obviously this is the DNS service inside the AWS. So these are the few of the services inside AWS, but you can see here that we have so many features in this particular AWS, and it is one of the example of infrastructure as a service. Next we have platform as a service. Here you can see in the diagram that inside infrastructure as a service, the provider responsibility was to provide you up to this layer.
But in case of platform as a service, you can see that operating system plus the infrastructure software will be provided by the provider. Now, what is the responsibility of the consumer? That they can run their application on the top of infrastructure provided by the provider. Now, it's very important here to understand that this type of cloud or this type of offering is done from Microsoft, one of the leading inside platform as a service provider. And here also you can see that they have this much of global presence. Okay, so across the globe they have their data centers. From there they can provide such sort of say platform as a services. It's very easy. You can go and you can create your trial version just to verify that what type of services there in their Microsoft Azure portal. You can go and log to https://portal.azure.com. You can create your account. Once you create account, then the thing is that go to azure.com. So the thing is that first of all log to azure.com, it will redirect it to this portal.azure.com. Anyways, once you create your account, then you will get one nice tour. It will show you that okay, do you want to create your resources? From here you can create the resources. Then you have the list of services. The top services are here, but you have the list of services. Now coming to these services, you can see here we have services related to database, we have services related to virtual machines. That means we have supported operating systems such as say Linux, Windows, and other operating systems as well. You can verify that. Then you can see that we have load balancers, we have a storage, we have virtual network, we have Active Directory, monitoring, advisory, security. So whatever things are applicable for infrastructure as a service, you will get all sort of information or services inside this portal. Further you can move, you can have this nice search bar where you can search whatever you want to search. Then finally you have this notification, you have help plus support, you have a directory and the subscription, and then about the account information. Okay, so very much it's something like if you know about that technology, you have to click and you have to use that service. That's it, because everything is provided by the service provider, and what you are doing, you are hosting your application. And that is the use case of platform as a service. The final topic in this section is software as a service. So far what we have studied, that inside infrastructure as a service, the provider responsibility is up to virtualization. Say in the platform as a service, the provider responsibility is to provide up to infrastructure software. And finally inside say software as a service, the provider responsibility is to provide everything. Okay, so what as a user or consumer you will do, you have a username and password, you can simply log to that particular service and you can use it. The best example for this is say Cisco WebEx. The other example are say Google Doc as well. So here you can see Google Doc and Cisco WebEx, but there are n number of services we are using for this. Simply we have one username and password and we can use it. Next we have say anything as a service. What does it mean? To this cloud evolution, what is happening now, the providers, they are adding anything as a service. So X, they can replace this, means this become the placeholder, and suppose here you can see desktop as a service. So if a cloud provider makes infrastructure as a service with a say software as a service, then they can provide something called DaaS, that is desktop as a service. Likewise, if you see here that the service provider, they add infrastructure as a service and say software as a service, and they can provide something called disaster recovery as a service. So anything they can mix, and finally they will come as a service acronym, something like that. Some other examples are here. You can see other examples are backup as a service, where again SaaS included with IaaS cloud, they'll provide backup as a service. Then we can see IP telephony as a service. Then you can see VPN as a service. So everything they can mix, means two particular cloud they can mix, and they can create one particular service. Let us start chapter number 3. In this particular chapter, we will learn about public cloud, private cloud, hybrid clouds, and some other terminology. We'll see that how Cisco take itself inside the cloud, because Cisco is not known for their cloud services. So how and what type of Cisco cloud services are available, we'll check in this particular chapter. So let us first start with public cloud. Now when we are talking about public cloud, obviously what will happen with help of public cloud, that you'll find it available everywhere. Means it has the highest availability, no problem on that. It will be available. But with some pros, it has some cons as well. So what are the disadvantages and what are the advantages we have with respect to public cloud? Let us see one by one. Say risk and challenges. So what risk and challenges we have with the public cloud? Because we are dealing with the public cloud, we may have data loss, and that in case of outage of major hardware failure in the cloud deployment, we may have that. So if there is data loss because it's a public cloud, then it's very difficult to measure at what point we have data loss. Likewise, because we are dealing with the public, say remember public means that you don't have much control over it. So once you are dealing with the public cloud, at that time, suppose if you have data breach, if you have data loss, then you have very less access, or you have very less privileges to determine all these things. Apart from that, because we are dealing with the public cloud, again, what about the malicious insider? Very difficult to figure out that as well, because whenever the service relies upon the employees, at that time, say some human motivations and some other stuffs can cause this malicious insiders. Then you can see, because again it's a cloud interface, it is one of the most unsecure interface, because you are exposed to the cloud. So public interface exposed to the cloud, so that's why insecure interface. Again, account of traffic hijacking. This is again one important point. Maybe your sessions will be hijacked because your traffic is going towards the public cloud. And finally, the shadow IT. The definition about this: if employees from your company deploy resources in the cloud without knowing the edge of the IT department, confidential may be wrongly. So what happens, sometimes we have some of the confidential data that we don't want to store in the public cloud, say some sort of government data, some sort of very important financial data. But due to lack of knowledge, if your employee store in the public cloud, that will be data policy breach or data breach. These are the risks involved in the public cloud. Now there is again one problem with the public cloud, that how you will control the cloud. So let us discuss the control challenges as well. Here you can see the first of the control challenge is the data location. So where is my data located? Do I have very minimum latency to retrieve that data? Because if the data is located in some other place, in some other data center, its geographical location is some far place, at that time it's very difficult to control the data location. Again, what is the flexibility or the elasticity of the control, means how much control you have to access your data. Then service admissions. So you can see here in the service admission that an administrative account may issue request for a specific public cloud services that are not authorized by the IT department. So do you have proper privilege for that data, for that say cloud control? Performance monitoring. Say if you do not have performance monitoring, how could you measure that, say, services A, B, C, they are using proper resources inside the cloud? So this performance monitoring is also very important, and it's very difficult to measure the performance inside the cloud. Finally, end-to-end management. So what does it mean by end-to-end management? Say in companies we have generally different line of businesses, we have different departments. Now then the problem comes into this, then how you can manage the services or manage the resources inside different line of businesses, inside different departments. So these are the things that it's very difficult to control inside the public cloud. Now coming to the cost risk, although we know that if we are using the public cloud at that time the cost will be less, because why? Because we are using the public cloud, because we are using some sort of resource infrastructure, so obviously cost will be less, but there should be some hidden cost that we don't know. So we don't know at the moment that these services we are not using, still the service provider is charging for these services. We don't know about, say, service proliferation. That means that without proper control of deployed resources, a company inherently allows sprawl of cloud services that are barely used. Means you don't know that you are using these services and you are paying for these services. Even if you are not using those services, you are paying for that. Okay, loss of revenue may be there. Why loss of revenue? Due to poor application performance, because I don't have proper monitoring for the application. I don't know the outcome of a application, means what is the performance analysis and how the application is performing. So at that time we may have loss of revenue. The other important thing is the cost modeling and the forecasting. Dealing with the public clouds at that moment of time, at that point, we don't know about the cost model, means which application in future needs some more bandwidth, needs more compute respect to application storage network. Those things we don't know. So how we can forecast a particular application inside a public cloud? That is again a revenue related thing. Finally, the business focus. Some of the CEOs, they want some standard services. So whatever we are using in the cloud, next year they can say, okay, we are not achieving our goal, and then do not use this. So at that time, how, according to business focus, they will take some decision. Then how we can author, or how we can what you can say, that accommodate such type of situation inside the public cloud. That is again one type of cost risk. Okay, let us move further. So now you understand these type of risk involved in a public cloud, and we will see that these risk can be solved in terms of private cloud, that we'll discuss in the next section. In public cloud, we have discussed that we have challenges with respect to cost and control. So cost and control, we have to compromise various things with respect to, say, cost and control. But while using private cloud, obviously it will be more secure than public cloud, because here this is private to the organization. But there are some things that we need to discuss here, or we need to compromise here as well in the private cloud, because it will be more expensive than the public cloud, that we'll see. So one of the emulation that we have in terms of how we can build a private cloud inside a public cloud is Amazon AWS. Amazon AWS is a public cloud. Inside that they have one service called Virtual Private Cloud, VPC, which is very popular at the moment in the market. With help of this particular VPC, we can have a private cloud, that is obviously virtual private cloud, inside the public infrastructure. Now it depends, whenever you are using a particular private cloud, it depends that what is your expectation, what is your outcome, what what is your expected outcome with respect to this particular server, and you have to check on the parameters of hardware, software, plus you have to check in the parameters of security control and cost risk. Okay. One thing I want to point out here, that this virtual private cloud, means that is emulated inside the public cloud, is not fully private cloud. So that you have to think again, you have to think that what is the baseline difference between complete private cloud and then you are using virtual private cloud. Okay, but still this virtual private cloud from Amazon is really very hot in the market, and so many organizations they are using it. Now if we are using the public cloud, so obviously we have some sort of benefit. So let me highlight what is the major difference between public and the private cloud. So suppose if I am using the public cloud, obviously public cloud has broad network access with respect to private cloud. So here it will win. Then again, if we check what is the operational cost or what is the capital expenditure, again you will find that public cloud will less cheaper than the private cloud, because for private cloud obviously you have to pay more for the services. Again for the elasticity also, because this is a public cloud, so public cloud can elastic more than the private cloud. So these things you have to keep in the mind, and that's why VPC, when it is coming into the picture, it is giving the feature of both the public and the private. So that's why we have all these check marks inside Amazon VPC. Finally, let us check what are the examples for most popular private cloud. You can see here Cisco is coming into the market with Cisco One Enterprise suite, and we'll discuss this in the upcoming sections, that what are the components inside the Cisco One Enterprise Cloud suite. Apart from that, we have Microsoft Azure, we have VMware vCloud suite, and then we have OpenStack as a open source. So these are the private clouds present at the moment. Let us continue our study about the cloud. Next we have community and hybrid cloud. Now we have seen that we have pros and cons for both the public and the private clouds. Then we have the other option that we can use the community cloud. Let me show you the diagram. Community cloud means few of the organization they can use shared resource inside the cloud. Now what is the loophole or what is the problem with such type of community cloud? That it has a scale limit. So you can see here that this community cloud are suitable to a relatively small number of companies from industry represented by common interest of compliance standard. That means it can't scale much, so that's why we need some sort of hybrid cloud. So let us see here what are the advantages and disadvantages of the public and the private cloud, although we have already discussed this. But again, let us list out all these advantages and disadvantages. First, with the public cloud, you can see the advantage is OPEX model, scale, high accessible. The disadvantage is shared resource, less secure, weaker control. That we have already discussed. With respect to private cloud, we have dedicated hardware, more secure, customizable, but the disadvantage that they are expensive, they are less scalable, hard to standardize. Okay, so we have plus and minus for both the public and the private cloud. So better we use such type of model that we can use both the features of public and private cloud, and yes, we can use that. So here in the diagram you can see that from private cloud I have some sort of secure tunnel. We'll see this type of secure tunnel and what is the name of secure tunnel, what type of connection I have in between the private and public cloud. We'll see in the upcoming sections. But here you can see that we have some sort of secure connection between the private and the public cloud, and then we can use the features of both the public and the private clouds. This is the last recording in this section, and we'll discuss about Cisco Intercloud. Cisco Intercloud simply means that what is the Cisco approach that we can connect the various clouds. Before discussing that, let us discuss that what type of technologies we have at the moment along with the cloud. One of the neat technology we have is bring your own device, means you can come with the roaming devices. Once you are inside the premises, automatically your device will get IP and that will connect to the network. That is the bring your own device. The other important research area at the moment is the Internet of Things. Now, how this Internet of Things is going to be implemented inside the cloud, or how a particular company or a particular organization can interact with Internet of Things devices plus the data, that is again one huge topic at the moment in the IT. Now these particular Internet of Things, actually they are some devices where we are putting the sensors. Inside that sensor we are running some sort of, say, internet, or you can say some sort of operating system which is capable of being monitored by some cloud-based or maybe some IoT-based directors. One of the director is, say, fog. Fog is one of the director from where you can monitor all the IoT based devices, because these IoT based devices, they are sending their request and reply and their processing data in the form of, say, sensors, because these sensors, they are delivering the data and all the stuff inside that in the IoT. Then we have this big data. Actually this is one old concept. It's not very new concept. The big data, one of the example of big data is the Hadoop, that is there to run or execute real-time data, and you can have input in terms of mobility, social media, IoT. Means it is there to process huge amount of data, and huge amount of data that can be real-time data that we are using in the social media or Internet of Things or the mobility data. Okay, so along with cloud, these things are also going parallel. Now let us discuss about this intercloud. So we are very much familiar about the internet. What is internet? Internet is nothing but, it's a network of network. So many networks, when they are collected together, they form one big network, that is internet. Likewise, this intercloud is nothing but it's a cloud of cloud. Means if so many clouds, they are clubbing together, they form intercloud. Now what is the Cisco take here? You can see here that Cisco with the partner clouds, they can connect with the enterprise private cloud, they can connect with the public clouds, and again we have this cloud intercloud services, so that they are going in hand like that, hand on hand. Means you can connect seamlessly between private to public cloud with some sort of technology. We'll discuss in this particular section what are the technologies used to do this interconnect, and let me show you the diagram, then you will understand. First of all, these are the terminologies used for the interconnection. So we have Cisco Intercloud Fabric, that is ICF. We have Cisco Intercloud Fabric Director. So we have ICF, means we have Cloud Fabric, and then to monitor, to track all the instances to all the services inside that fabric, we have Cloud Director. We have Cloud Extender. We'll see that we have ICS as well, that is the Cloud Switch. Then we have Virtual Security Gateway, VSG. Then we have obviously the cloud-based routers, something like CSR. So let me show you the diagram. See in the diagram that I am extending the cloud. So suppose I have one cloud here, I have other cloud here, and in between that we have this intercloud extender. I am extending the cloud from one place to other place. Then I have secure tunnel, means to exchange the data of the VMs from one cloud to the other cloud. We have secure data and secure data tunnel. And not only that, you can see here that between this ICS and the VMs we have secure tunnel. Between this ICS and CSR we have secure tunnel. Between this ICS and the security gateway we have the secure tunnel. Okay, so once I am extending the data, or once I am extending the cloud from one cloud, say public cloud to private cloud, these things will be there. Now, what are the main terminology used in our case? You can see here that I have Intercloud Fabric Director. With help of director, I can interact the management plane of VM. We'll learn more about this VM and how this VM management servers works. One of the VM management server is vSphere server or vSphere client. We'll see that in the upcoming section. So from this director, I can interact with the VM manager. From this director, I can interact with the cloud switch or intercloud switch. With this director, I can create tunnel between the cloud extender and the cloud switch. So all sort of stuffs we can do with help of this particular director. And here you can see the list of the services that this particular cloud fabric director can do. Let me list all those things. So establish a management connection to the server virtualization control, that is the VM virtual machine manager from your organization to the VM manager. That is the one task. The other task is configure the secure connection between public and private cloud. Good. Then add and manage the end users. That is again the work of the director. Then configure policies that govern workloads. So you can create the policies, you can customize the portal, you can monitor the hardware capacity and the utilization. You will get nice graph that from where you can monitor the capacity and the utilization per user. We have the service catalog feature to enable the end user for the provisioning of the services. Then finally we can configure the virtual server templates and image as well as the end user access to them. Okay, so you can see that we can do lot many things. So not only we can do the management, we can create the secure connection, we can add the users, we can configure the policies, we can customize the portal, we can monitor the hardware, we can create the service catalog, we can configure the virtual service template. That will be the use of our director, or say intercloud fabric director. Now we reach to chapter number 4, behind the curtain. And this particular chapter, actually this is very important chapter where you will understand about the cloud and how we can operate inside the cloud. Because say if we are talking about something traditional IT infrastructure to reach up to cloud infrastructure, what are the key goals, or what is the major steps that we reach from a legacy IT infrastructure to the cloud? So you'll find, to reach to the particular cloud you need consolidation, virtualization, standardization, automation, orchestration. Okay, so these are, say if I count 1, 2, 3, 4, 5, these are the 5 main pillars that can be performed to reach from a traditional network to fully automate cloud infrastructure, or to reach up to cloud if that is your goal. Now, if you check your traditional network, or if you check your network infrastructure, some sort of consolidation, some sort of virtualization, some sort of standardization, and now people are talking about automation, means to reduce the overload of the manual operation. You can write a script that will be assumed like 100% error free, that you can run and execute the task inside the IT operations. The next phase is obviously the orchestration. For the orchestration, actually we have tools, something called UCS director. We'll learn more about UCS director in the upcoming sessions recordings. Okay, but this is the overall goal, to reach from the traditional network to reach up to the cloud infrastructure. Okay, now Cisco One, more precisely we can say that this is something like Cisco One Enterprise Cloud Suite. Means it contains so many other features as well. This recording I will show you about Cisco Prime Service Catalog and different components inside the Prime Catalog. But in general, overall, if you see what is the overall overview of the say Cisco Prime Service Catalog or Prime Service Catalog. So you will find that okay, you are there in your traditional network, your goal is to integrate with the cloud infrastructure. Now this particular thing is the inside picture of the cloud infrastructure. This is cloud infra. Okay, now we have three main parameters here. What are those three main parameters? So we have something called cloud portal, and this is that I'm mentioning that Cisco Prime Service Catalog, CPSC. I'll show you, I'll log into this and I'll show you that inside this cloud portal what you will find. So a end user, first of all, it will log to the portal, that is the service catalog portal, and from there it can integrate with UCS director. So this is cloud orchestrator. One example is UCS director, and then you can measure the service. So inside UCS director, when I cover UCS director, at that time I'll show you that inside UCS director we have cloud meter as well. Okay, so from here you can reach to cloud orchestrator, and then you can provision different type of services, say services like network, services like storage, services like virtualization, services like integration with VM manager. So all sort of services you will get from your service catalog and the UCS director. So you can think this as a cloud software stack. From cloud software stack you can interact with various IT infrastructure, or here we have cloud infrastructure with respect to say network, storage, virtualization and VMware or VM manager. Okay, now if we log to Cisco Prime Service Catalog, it will look like this. So let me log inside this and let me show you some of the features. I logged inside and you can see that you have, say, first of all you have this welcome message that welcome to your IT as a service storefront. Cisco Prime Service Catalog is the ITaaS catalog providing self-service for private and hybrid cloud. So that is very important that we have self-service for private and hybrid cloud. Okay, and it can provide out-of-box integration for UCS director as well. Correct. Now if I scroll down here, you can see that I can integrate this particular cloud with enterprise IT service like Epic, private cloud infrastructure as a service. Then I can integrate with cloud computing services like Cloud Center, Amazon Web Service, Microsoft Azure service. Then inside cloud services you can see these are the operating systems, these are the applications. Inside private cloud infrastructure you can see servers deployed via UCS directory. Cisco Prime Service Catalog is a ITaaS providing self-service, all those definitions. Then finally inside the ACI we can create tenant in ACI, we can create 3-tier profile, we can deploy new equipment, deploy ACI to new equipment like that. Suppose if I click here, and here you can see that it's very much similar that you are purchasing something from Amazon. Correct. So what do you want? Order for others, order. So suppose if I click order, then I'll get new page. In this particular new page it will ask about deploy ACI to new equipment. Yes, I want to submit it. Okay, so this is the way basically you can simply go to the catalog and whatever you want to deploy you can deploy it. Okay, so I hope this particular section will be very informative to you and you learn new things from this video. I hope you understand the service catalog. The next topic is cloud orchestrator. Now this cloud orchestrator can do so many things. And first of all I will list all the application, then I will log to UCS director, that is one of the cloud orchestrator from Cisco, and then we'll match all these things that we are going to discuss here. Okay, so let me one by one highlight all these things that what my UCS director is capable of. Okay, so first of all you can see here in the slide it can manage and support heterogeneous data center. Okay, so not only one but mix of data center it can support. And then after, you can see here that include compute, network, storage, virtualization, resource from multiple vendor. So irrespective of Cisco, they can support NetApp, VMware, EMC, other vendors they can support. We'll see that. Okay, that is the one of the feature, that heterogeneous data center. So let me mark only this portion. Even you can note it down as well, heterogeneous data center plus multiple vendor. Okay. Second, it can provision physical and virtual compute layer 4 to 7 network services, storage resources. So again, the second point is also very important, that not only it can provision physical but virtual resources, that is compute as well. That is the second point. So first point, second point. Third, create and implement single and multi-tier application profile. So it can create application profile. That is the third. So if we highlight, it can support heterogeneous data center. Let me circle it. With multiple vendor support it has. Then physical and virtual compute application profile. Fourth one, define application container that describe a set of tier that include physical or virtual compute resources, that connectivity policy, communication policy. You can further define those application containers. So it can define application container. Okay. So now we have four important points, that heterogeneous data center, multiple vendor, provision of physical and virtual compute, create and implement single and multi-tenant, say, application profile, define application container. All these things I will show you while logging to UCS Director. Then establish multi-tier environment, you can see here, so that users, whether internal or your company or external, can work only within the secure constraints of their own resource pool. Okay, so it can establish a secure multi-tenant environment. Point number 5, implement metering. So this metering is actually how you can measure the services, or how you can measure the resources. That is the third pillar. Remember, we have three things inside our cloud stack. So one was service catalog, the second was orchestrator, and third was metering, how you are charging. Okay, so inside this UCS directory we have both the option. Not only it can do the orchestration, but it can do the metering, plus very important thing, it can do the automation as well. So it can do the automation with the IT resources and implement a process oriented approach. Okay, so it can do the automation feature as well. Now let me log to UCS Director and show you all these things. Inside UCS Director, and let me highlight you all these things. So here you can see, first of all, inside the dashboard we can see, so what are the things we can see? So VM, active versus inactive, UCS server inventory, UCS server associated versus unassociated. So we have a dashboard here. Great. Then I can go and click to converged. So if I go inside converge, you will see the multi-vendor support of UCS Director. So not only it is supporting VMware virtualization, you can see virtual VMware, shared vCenter. It is supporting a Cisco compute. It is supporting Cisco network, that is the VSM. Again, this is something like a virtual supervisor module, or we can define it. If you go click here, you can see, yeah, this is Nexus 1000V VSM virtual supervisor module, and we have two things. We know that I think we know that we have virtual supervisor module plus Ethernet module, so VIM and VSM. Anyways, then it is supporting NetApp, the storage as well. So here you can see that storage from NetApp. All these things we have here inside this converge. If I go and check hyperconverge, so it has hyperflex and virtual SAN feature. Then here in the top you can see it is supporting virtual and physical resources as well. So what are the things inside virtual? It is supporting virtual compute, storage, network. It is supporting physical compute, storage, network. So compute storage network with respect to virtual and physical it is supporting. Then inside the organization, service catalog, approvals, summary, virtual resource, physical resource, chargeback. These chargebacks are actually very important. This is something like metering type of thing, that is the third feature inside the cloud stack. Then finally it can create policies. So you can see it can create application container that we have seen in the PPT. Then virtual hypervisor policies. So not only it can create the containers, but it can create the policies with respect to virtual, service delivery, compute, storage, network. Again, with respect to say physical infrastructure policy like usage manager, central NetApp, other thing. Okay, then finally you can administrate this particular software based machine. So you have license system, LDAP integration and other stuffs. Now this cloud sense and the chargeback, these are the metering type of thing. So this cloud sense here, and we have seen the chargeback as well. Okay, so this is the overall summary of our UCS director, and I hope you understand the dashboard and the basic features inside this particular UCS director. In our cloud software stack, we have cloud meter. What is the use of cloud meter? So the use case of the cloud meter that we can see here, that it concentrates service management or measurement in a cloud computing deployment. Simply say we have three components. One is service catalog, one is the orchestrator, and one is the cloud meter. Now the use of cloud meter that whenever the orchestrator, so whenever we have request for deployment to deploy something, say in terms of physical or virtual, at that time cloud meter receive notification from the cloud orchestrator informing when infrastructure resources were provisioned for the cloud consumer. So it will receive the notification that a particular consumer has done something. Obviously it will receive the notification from the orchestrator. That is the first goal. The second thing it has, supports the creation of billing plan. The third, summarize receive information, eliminates error such as duplicate data or some other parameters, such as generate on-demand reports per user group business. So you can summarize like this, just for sake of simplicity, means it is one component inside the cloud stack which is used to receive the notification, one, which is supporting the creation of billing plan, two, summarize the receive information, means it will summarize do you have duplicate data, what is the actual bill for a particular consumer or the customer, and then finally provides on-demand report to the cloud portal. Okay, so these are the use of the cloud meter, and in short it is doing the measurement or measuring of various application or resources inside the cloud suite. What are the functions or which type of application or modules we have inside say UCS director to support this? So inside UCS director we have chargeback module and we have cloud sense tab. We have seen in the last section that how it looked like. If you go inside say UCS director and if you check this cloud sense, if you click to the cloud sense, then you will get list of billing plans. So here you can see that application, container report, billing report for consumer, then inventory report, utilization report, NetApp report, means all sort of reports we have with help of this particular cloud sense. Okay, and again we have this chargeback module, enable detailed visibility into the cost structure of the orchestrated cloud infrastructure. Okay, so I am doing the summary here. This cloud meter will do nothing, but with help of chargeback, so chargeback and with help of say cloud sense, it will measure the services, it will summarize the bill, and it will receive the notifications. Okay, so I hope at this point of time you understand this particular metering, cloud metering services and a use case. When we are talking about the cloud journey means that you are moving your legacy IT infrastructure to the cloud. Now, to move from legacy infrastructure to the cloud, you have 5 parameters, or you have 5 stoppage, you can say. So first of all, it will start with consolidation, then it will move to virtualization, then it will go to standardization, then it will go to automation, and finally we have the orchestration. Okay, so one by one I'm going to cover all these 5 parameters. In this particular recording, I will discuss about consolidation, virtualization, standardization, and automation. Let us start with consolidation. Here you can see in this particular diagram, you can see here that all the clients, say client A, B, C, they are using their own, they are using their own storage, they are using their own server, they have their own data center. So customer A has data center A, B has data center B, C has data center C. Okay, but suppose if we move all these infrastructure into the consolidated state, so at that time you can see not only you have the redundancy from the servers to the storage area network or towards the storage, but you can share the resources. So that is the overall goal of consolidation, is to share the resources. So the first step towards the cloud integration or towards the cloud move or movement is to do the consolidation, to properly share the resources. Okay. Now the second thing is virtualization, and it's a huge concept. Virtualization, one of the main player inside the virtualization is VMware, but now other companies, they are also doing the virtualization. If we see the evolution of virtualization, virtualization is not a new concept. Means this virtualization is a bit old, because if we see, say, VLAN is a type of virtualization. Inside Cisco, say inside Cisco Nexus Switch, we have concept of VDC, virtual device concept, content or context. That is also a type of virtualization. If we are thinking about, say, ASA firewall, inside ASA firewall as well you have context, means you can create virtual ASA firewall inside the firewall. So these virtualization concept is not, say, new, it's an old concept, but due to this VMware has done tremendous work inside virtualization. Initially they start with server virtualization, then they move into other products as well. Then they move something like, say, data center virtualization, their product is NSX. Then they move to SDN type of virtualization, say for wide area network, they also acquire some company. So this virtualization is again a huge thing. Not only we have virtualization in terms of network, we have virtualization in terms of storage, we have virtualization in terms of server as well. Okay, so this you can consider as second step to move towards the cloud. And the third step is the standardization. Standardization is important because you need some sort of a standard model, you need some sort of a standard parameter upon which you will define the resources, upon which you will define the compute, you will define the storage. Okay, so standardization will provide the uniformity inside the infrastructure, say in terms of vendor, model, version, storage, server, network, everything. Okay, so this is also very important, that we are moving our legacy IT infrastructure towards the cloud, or we are doing the cloud integration. Finally, we have automation. This automation is also a huge, nowadays, maybe you heard from last 2 to 3 years, everyone is learning Python, say Ansible, Perl. These type of languages are means used by the network engineers. Means initially, say 5 years back or say 6 years back, network engineers, they are not worried or bothered about the programming languages. Now network engineers, they start learning Python or other programming language or scripting language. Why? Because that is one of the use case, means automation use case, to move the traditional infrastructure towards the cloud. Okay, and that is one of the major milestone for a legacy IT infrastructure. Okay, now if we use the automation, what type of benefits we'll get? We'll get the benefit that whatever human errors are there, we can remove it. That is the first thing. Second thing, whatever manual operations we used to do, we can run a script. With that script, it will do all those manual work that we used to do within a fraction of seconds or maybe minutes. Okay, so these are the two things that with help of automation we have the concept of reusability. We can write a code, we can write a template, and time to time without any human error we can execute it. Okay, so we can remove the manual procedure. Then automation invariably transform provisioning, migration, and decommissioner. There are so many good scripts are there. Say suppose if you run those scripts, it will automatically do all sort of configuration. Okay, and then finally you can see that much as a modern industrial procedure line, the operational terms of an automated data center must design tasks that can be carried out. Software robots closely monitor their. That means that in short, what you can do, that you can write procedure codes or a script to reduce the manual workload, and you can gain the highest level of accuracy with help of automation. Okay, so let us stop here. In this session, I'm going to explain what is orchestration, application programming interface, that is API, and the RESTful API. Now, this is the fifth pillar when we are reaching from our IT infrastructure to the cloud with help of orchestration. And one of the example we have seen with UCS director, and we have seen that what are the use case and what we can do with help of UCS director. So in summary, we can do the consolidation. In summary, we can do the virtualization, we can achieve the target of standardization, and we can perform the automation. So all these things we can do with a orchestrator. Okay. Now the next topic is application programming interface. Now it is coming how we can configure a device. So device configuration we can do with help of CLI. Whatever Cisco IOS like Cisco routers and switches, we used to do the configuration with help of CLI. There is no problem on that. Even most of the virtual device or virtual device manager, we can do the configuration with help of CLI. Okay. Then we have SDK, software development kit, that is a collection of tools including code, documents, examples. Means it's a complete package. SDK is something like it's a kit, it's a complete package, and we know about this that okay, Java programming language, they are coming with say SDK. Now we have Python as well, because Python is one of the language mostly used within the network infrastructure. It's lightweight type of language. It's a interpreter type of language, means you can run it anywhere to any platform. It's something like that, means it's very lightweight and we don't need much much database or much libraries or binaries to run the Python. Simply we can execute this Python program. So most of the Cisco devices, they are supporting this Python programming. Okay, so that's why the use case for the Python is really very high. Then finally we have application programming interface. Again, application programming interface is a set of function variables, data structure that we can execute over a manager. With help of that manager, we can write those APIs inside that particular fabric. So what does it mean? I have one use case here. I'll show you in this particular session. What does it mean by API, and when we are integrating with RESTful API or REST API, what does it mean by REST API? REST API full form, you can see that representational state transfer, and then and when we add with API, what does it will do? So I have one example case here. Say I'm going to show you this example case with help of vManage network management system. So what is this vManage network management system? Example I have taken from Cisco SD-WAN called Viptela, and if you know about little bit about SD-WAN, SD-WAN is nothing, or SDN is nothing but the decoupling of the control and data plane. Even you can decouple with the management and orchestrator plane as well, but in loose term it's a decouple of the control and data plane. So your control plane will be hosted somewhere and your data plane will be hosted somewhere. Data plane responsibility is just to forward the data traffic, and control plane from where you can set the policies, routing, securities, all sort of parameters. Okay, now to send the instruction from the control plane to data plane, you can do various things. So either you can use CLI, there is no restriction, or you can use say API. Say in this example, suppose I am using RESTful API, so you can see here that I have this option of doing RESTful API. Either I can use vManage, that is one sort of management, what you can say, the software inside SD-WAN Viptela. Yeah, it's a software. So here you have vManage, say this is vSmart, this is vEdge. These are the terms inside SD-WAN, Cisco SD-WAN. Anyways, we'll not go inside what these terms do, but we are just checking that I have one control plane and bottom I have data plane, and this data plane I can send instruction with help of control plane. That is the overall goal here, and practically we can use API. With help of API calls we can do all sorts of stuff. So what type of stuffs we can do here? We can do certificate management, we can do configuration, we can have device and device inventory, we can do monitoring, real-time monitoring, troubleshooting, means all sort of stuffs we can do with help of RESTful API. And how we can do that? Obviously we have this REST APIs and they have some methods, they have some procedures. So what procedures they have? So inside HTTP or HTTPS they can use get, put, post, delete. Get means to retrieve or read information, put means update an object, post means create an object, delete means remove an object. Okay, so these are the functions inside the HTTP or HTTPS method. With help of those we can achieve the target. Okay, and for practical, either we can check Cisco SD-WAN Viptela, that is one example. The other example is say ACI infrastructure where we have Epic controller. So with help of say RESTful API we can configure Epic controller, and from that Epic management plane we can configure rest of Leaf and SPI inside the LAN infrastructure. Final topic in this particular section is the OpenStack, and OpenStack was basically developed by NASA and the Rack Space. You can see here in the 2010. And why they developed that? Because they wanted a open type of source or open software to build public and private scalable cloud. So that was the reason to develop OpenStack. Okay, now what is the good thing about OpenStack is that it is open source software, so anyone can contribute on this. That is the good thing about OpenStack. The other thing here, you can see that this OpenStack, it can be managed via web-based dashboard or via OpenStack API. Okay, And finally, the third point is the OpenStack implementation consists of deployment of multiple services which are developed in individual development project. Okay, so that is the same thing that I told you, that the companies, they can develop their own way of or their own form of OpenStack, and it is a type of scalable, say, public and private cloud. Okay, so we have some terms related to OpenStack. Now, when we have a study about AWS, at that time I told you that whatever cloud you study, no worries, on all those clouds you will find services related to network, storage, compute, database, security, other stuffs. But these 1, 2, 3, 4, 5 services will be major. And in all the cloud you have these 5 services at least. Okay, so here you can see the keystone provide identity service. Identity service is something that will fall under security. Nova, that will provide the compute. Okay, glance, this coordinates the image that will be used to boot virtual and physical devices. Then we have neuron, that is actually very popular. Neuron controls networking resources to support cloud. So see, neuron networking. Then we have Swift, offer data storage. Now this is belonging to the storage. Then we have Cinder, this is also belongs to storage. Then we have Heat, that is used to manage entire orchestration of infrastructure and application. So this is something related to orchestration. Then we have Tube, provides a scalable and reliable database. So you can see here that everything will fall under these criteria, say network, security, compute, storage, say management, database, even monitoring. So all these application one by one, if you compare, you'll find these acronyms that is used here, or these services that is used here inside the OpenStack. Then we have Sahara, that is implements data sensitive application. Then we have Zakr, offers multi-tenant cloud messaging. Barbican, designed for secure storage. Designate, provide DNS. In AWS we have something called Route 53, which is providing the DNS. Here we have this Designate. Then we have a Manila, builds shared file system. Magnum, orchestrate Linux containers. So we have service related to containers as well. Then Congress, offer governance and compliance services. Finally we have Mistral, creates and schedule the workflow. So if you learn the entire cloud paradigm, entire cloud infrastructure, different type of vendors, say OpenStack or Amazon or say Cisco or some other vendors, they are doing the same thing, but to achieve that same target, they have their own services. So maybe the use of this particular designate inside OpenStack will be exactly same, that will be the use of, say, Route 53 in Amazon. So likewise, you can compare the various services across various service providers. Okay, so let us close here.
Then what is server and operating system? What's the basic definition of server? Server means that someone who is hosting services, someone who is providing services. But you can see that server, they have various components, and these servers, they are taking requests from the client. They are processing those requests and providing certain services. Now the server consists of the CPU, the internal storage, main memory, interface card. Means there is various input and output uh, processing. There is various components inside the server. Uh, After processing those servers, they are providing the services. Correct? Now, what is the main component, and to be very precise, what is the main software component we have inside the server is nothing but the operating system. Now, the operating system is someone who is the brain. And you can see the definition of operating system. A very standard definition is that operating system can define as software that control computer resources and provide common services for other computer program that run on top of it. So for example, in my laptop I have Windows operating system, and once I have Windows operating system, then I have different applications. So for example, I'm using Gmail, I'm using web browsing, I'm watching YouTube, I am uploading courses to Udemy, watching courses from different vendors, uploading courses to here and there, doing some chat, playing game. Means all those applications that is hosted and that is actually connected with the operating system. So operating system you can think as a boss who is providing the time slots, who is providing the instructions. So you can think that operating system in the core and a small programs, they are connected somehow with this main program, this operating system program, and then operating system, they have their own mechanism to provide time slot, to provide space, to provide computation, everything that is provided by operating system. So you can think this is the heart inside the server, and which is responsible for all to run all the other programs. Main vendors: Microsoft, Linux, FreeBSD, Apple, Android, Cisco iOS, Chrome, etc. Some of the operating system here, you can see the difference that they are used inside the laptop or server, etc. But some of the operating system, they are used inside the networking devices like routers, switches, firewall, etc. etc. Correct? Now here you can see the view of the operating system. So you have the kernel space, that is the low level programming, and that is the program that is associated with operating system. And then maybe I have user space and various applications like email, chatting, online, um, video game, etc., etc., etc. And these applications, that is program, these kernel programming, that is again the program, they are associated, and again these hardwares that you are seeing, so for example RAM, NIC, disk, they also have their own programs. So actually behind the scene, all the programs from high level language to low level language, they used to consult to each other with different type of messaging bus in between them, and they are providing the output as requested as an input. So we are giving some input, processing happening, that is the program is happening, message bus, they are receiving the instruction, and then they are providing the output. So that's the basic of the operating system. Next section we'll learn about that how this hypervisor operating system works, and they are helping us to reduce the overall cost, reduce, or we can say the more efficiently we can use the different type of hardware component or resources with help of emulated uh, features that we have inside the hypervisor program. What is virtualization? And with help of virtualization technique, what we are going to achieve. Last section we study about the servers and the definition of server and operating system. You think virtualization is a type of emulation where you have fixed hardware. On top of that, you can use some emulated program, and then you can install various operating system. So what is the traditional way to install an operating system? Say I have my laptop, I can go to my laptop. In that laptop, that is my fixed hardware. Inside that laptop, I have fixed CPU, memory, RAM, etc. So I have my laptop, and on top of my laptop I can install operating system. So for example, I'm using Windows operating system. Now think like this, that you have the hardware. So I have the hardware. On top of that, so let me write here hardware. On top of that, I can install some sort of emulated software. So I can install emulated software. This is actually termed as a hypervisor. So I can install a hypervisor on top of hardware, and now whatever, say for example, RAM, CPU, network interface card, memory, etc. I have, those fixed hardware they can use, and they can think that I have my own RAM, CPU, network card, memory, etc. I can install operating system 1, operating system 2, operating system 3. Obviously there should be some limit that how many operating system you can install. I'll write here N on top of the fixed hardware and the hypervisor. Now if we use this particular emulation or emulated way to install the operating system, actually this is termed as a host. So on top of host, and in this course we are going to study about VMware hypervisor, that is nothing but ESXi. So on top of host I am installing a various guest operating system. So these are nothing but guest operating system, and in this way we can save a tremendous amount of hardware resources, and that's a term, actually something termed as a server virtualization. Now there is difference between the server virtualization and hardware virtualization, and you will understand this thing coming forward or going forward. So for example, when you uh, perfectly use the hardware resources, that is nothing but the server virtualization. And suppose if you know the term, so for example, unified computing system inside Cisco. So you have unified computing system. Inside that you can install so many servers with server profile, etc. That is one of the example of server virtualization. The other example, just now we have seen that you have one big hardware resource, and then you are installing some sort of hypervisor emulated software on that, and then you are installing the guest operating system. So that is the example of server virtualization. When we are talking about network virtualization, nowadays everywhere, so this network virtualization is used. Say for example, SDN solution. Say for example, my SD-WAN is a type of network virtualization, or inside that I have network virtualization. Say for example, Cisco application centric infrastructure, VMware NSX. These are using network virtualization concept. Uh, Easy example, can I give the easy example? Yes, the easiest one is the VRF, virtual routing forwarding. This is again a type of network virtualization. Okay, so virtualization technique means, now here you can see this is the example of server virtualization. You have, suppose if you have one hardware, one operating system, that is we are not using any type of virtualization, but you can use in between the hypervisor or the virtualization software that is known as a host. On top of host we can have n number of operating systems. So here you can see OS, different operating system we are installing, and then on top of that we are installing the applications. So in this way we can reduce the cost, and it is actually quite efficient. Almost all the companies are using that way, this method only. Again here you can see that you have multiple ESXi, so you may have host 1, host 2, host 3, few of the host having a few of the operating system or guest operating system, few of the host having few of the guest operating system. And suppose if you want to manage entire infrastructure, later on we'll see that how to manage the hypervisors, cluster of host, data center, etc. So we have one VMware popular tool or popular software or suite of software, protocol suite, whatever you tell this is, you have one management layer, that is the vSphere server and vSphere client. And in our lab also we are going to use the vSphere client to manage. So here you can see that you have the server, and here you have the uh, client, and with help of one web browser, one application, you can manage the entire big infrastructure. So now you can see the complexity has been reduced, the overall virtualization of hardware has been enhanced, and in this way companies they can save lot of money. So now what is the hypervisor? The definition of hypervisor is a hypervisor can be defined as a software that can emulate the hardware like CPU, memory, RAM, and storage, etc. for the installation of guest operating system. In the context of server technology, a hypervisor is essentially a program that allows creation of virtual server. So whatever we have discussed, the same thing. Again, if you want to see this diagram, you can see that you have your server, your hardware, you put your operating system and the application. But in this way, you are not using the virtual way or you are not using the hardware resource efficiently. Instead of that, what you can do that you have your hardware, put the host or the hypervisor, and on top of that you put operating system and application. So easily you can enhance the performance, reduce the cost, better use of the hardware resources, single plane of management for different guest operating system or application, etc. Again, we have one more diagram here. You can see that you have one big framework. You have fixed hardware, the 86 architecture. You have your virtualized software here. And on top of that virtualized software, you are installing operating system application, operating system application, operating system application. Now, all these CPU, RAM, NIC card, disk, whatever you're seeing here in the diagram, actually those are termed as a virtual RAM, virtual memory, virtual NIC, etc. So you have your real CPU, memory, NIC, disk, and on top of that you are using everything as a virtual. And that's the power of the hypervisor we have. In this course, basically we are going to focus on the VMware ESXi, but there are so many good vendors. There are vendors like VMware ESXi is a hypervisor, Microsoft Hyper-V. These are the popular vendors. Then we have the Linux KVM. These three are the topmost trending hypervisor. Apart from that, we have the Red Hat Citrix Zen Server. This is also very popular, Citrix Zen Server. We have Oracle VM. Then we have, we'll see later on that we have two type of hypervisor as well. Then you have Microsoft Windows Virtual PC, Oracle VM VirtualBox, Pallor Desktop for Mac. You have these many vendors who are providing these hypervisor softwares. So I hope you understand that what is the meaning of hypervisor, why we are using the hypervisor, and in long term how we can go and manage them. Let us quickly discuss that what type of hypervisors we have and what is the benefit we have with the hypervisor. So clearly you can see that in case of physical server, you have your hardware, operating system, and application. In type 1 type of hypervisor, you have your bare metal, your server. On top of that, you are installing the hypervisor, and then you have the guest operating system and the application. In type 2, you can see that you have the bare metal, or you have the server, operating system, and on top of operating system, you are installing the hypervisor and the operating systems, like the guest operating system and the host operating system. Now, this type 1 is actually popular and it's quite hardware efficient. So this is the preferred hypervisor technology that we have, and most of the places that companies they are using the server. So you have the hardware, you have the host operating system, that is nothing but the hypervisor, you have guest operating system, and then you have the application. Now doing so, we have benefit. Let me quickly show you the benefits. We can reduce the capital and the operating cost, minimized or eliminated downtime, because in this case you may have redundant host. So suppose if one host go down, still you have your different host and your VM can move to that particular host. So that's why it is redundant, means you have the redundancy in terms of host, in terms of guest operating system, plus the application redundancy. You will see the design and architecture of virtualization with respect to, say, for example, VMware, and you'll find that the downtime is reduced. Obviously, if your operation cost is less, your downtime is less, it will increase the productivity, efficiency, agility, and responsiveness. Faster provisioning of application, yes. We'll see that how easily you can install a guest operating system on top of host. It's very easy. You can do with few clicks. It has greater business continuity and disaster recovery. We have some mechanism, we have some methods that we can do the disaster recovery, and it will simplify the data center management, and that's the key. So when we are simplifying the things with higher efficiency, agility, more productivity with lower cost, that's the goal of all the businesses nowadays. Let us discuss about the virtual machine and try to understand that how we are going to install over the hypervisor. We'll see the installation lab in upcoming session, but here we'll try to understand that how it will be emulated over the hypervisor or over the ESXi. So now what is happening, that we know it is clear up to this point that I have the server on the top of server. So I have server. On top of that, I have ESXi or the hypervisor. And on top of that, we are going to install the operating system. Those are nothing but guest operating system. Now these guest operating system, whatever actual hardware is there, they are sharing. So inside that guest operating system, they have shared, or you can say that they have shared actual physical hardware in terms of virtual CPU, virtual RAM, virtual hard drive, virtual storage, virtual NIC. So everything is virtual. Whatever actual we have, all those emulated virtual hardware they have. That's the first thing. The second thing, and very important thing we'll see in the upcoming slide, is that everything is in form of folder. Okay, so here you can see I will log into the vSphere client, and I'll show you that you'll find that the CPU is virtual CPU, virtual memory, virtual hard disk, everything is virtual here, correct? So I will log into that vSphere client and I'll show you. The next important thing here you can mark or highlight is that everything is in the form of folder. We'll see that. I'll show you that database and the folders inside that. But now let's see the terminology and the extension. So we have .vmdk extension. What is this? This is nothing but your internal storage. So your virtual disk internal storage having extension .vmdk, correct? Obviously VM is for virtual machine disk, that is internal. Then you have the swap memory, that extension is .vswap swp, and that is used for what? So here you can see that is used for virtual memory whenever the process running on the VM reaches the VRAM predefined limit. It's nothing but virtual memory. Virtual memory is swap, vswap. Virtual storage is v.mdk. Then you have the log. Why? So there in the .log extension, all stuffs related to troubleshooting purpose they will store. So the file store all the information a VM produces for troubleshooting purpose. Then configuration, that will be stored inside .vmx. So here you can see .vmdk, .swap, .log, .vms. Why I am explaining this thing? Because when I log into the vSphere client, from there you can go and check these folders and extension. So once you are seeing .vmx, that means it is there for virtual RAM size, vNIC information, and other references for the other files. Then we have non-volatile RAM, that is .nvram extension. Again, the use of non-volatile RAM, here also the use is same, correct? So these are the important extensions we have, but apart from that also you will see further more extensions. I took the snapshot from there from the file system, and here you can see that .nvram, .vmdk, .vmst, vmx, .log, etc. Okay. So what's a virtual machine? Virtual machine is nothing but a machine which is installed on top of hypervisor as a guest operating system. They are using the virtual resources. Actually, they are using the actual resource in terms of virtual resource to run their operating system, or you can not or but and you can install the application on top of operating systems. So let me quickly go and log into the vSphere client. From there I will show you the virtual machine, how it looks like, and the various type of file and folder system. Here I'm inside the vSphere client, and we'll see later on that what are these entries or items inside the dashboard. So think this is a vSphere client dashboard where you have host and cluster, virtual machine template, the storage, networking, content libraries, global inventory system, and other stuff. So we'll see that these things later on. At the moment I am focused upon only on the VM virtual machine. So what you can do, you can go and click VM and template. Once you click, you can see a list of VM over the ESXi over the hypervisor. We'll go and check ESXi and their architecture as well later on. But suppose this is the tiny Linux, and I want to see the summary, what type of virtual hardware it has, what type of emulated hardware it has. So here you can see the list of hardware, the VM hardware, the CPU, memory, network card. I will discuss more about network card later on, video card, VMCI, and the other hardware related stuffs. Storage area, memory uses, and CPU info, the IP address and the hypervisor. ESXi 02a corp.local. It is having 32-bit of Linux operating system. The hypervisor is ESXi 5.5. These are the tools that is running. Okay, so this is the hardware. Now if I want to see that their file and folder structure, I can go to the data store. It is attached with this particular data store, and I am very much looking for my tiny Linux file and folder system. Here on the top you can see you have this expand button. If you go and expand that, you can see it is coming up, and now if I go and click to tiny Linux, the folder will open, and inside this particular folder you can see all the extensions that we have discussed: .nvram, vmdk, vmx, log, etc. Correct? So this is the way that we can go and check few of the things inside that. Later on we'll study more and more about this, and we are going to learn each and everything. Let's go through the hypervisor architecture of VMware ESXi. Now in the diagram you can clearly see that there are multiple ways actually to do the management of the hypervisor and the associated guest operating system, etc. So suppose if we have cluster of hosts, say ESXi 1, 2, 3, and I will log into the vSphere client, and I'll show you that from one particular management plane, and that is nothing but a web browser, from single web browser, with help of vSphere server, with help of vSphere client software, you can actually manage, or you are able to manage, the entire VMware infrastructure. That's the uh, overview or the top view of the architecture of the VMware. This is the VMware client, that from where we are going to manage everything. This is the web browser, and here you can see that vSphere web client is a web browser based application that you can use to manage, monitor, and administrate the objects that make up your virtualized data center. And that's the key. See, from one application I am going to manage the entire virtual data center, And that's the power we have from the VMware. And that's the reason that VMware increased so much in terms of software defined data center. So from a single software, you can manage the entire data center objects spread across the globe. Now here you can see that what are the things that we can do from the vSphere client. We can go and check the health, the status, performance of the objects. We can do the management and the administration commands from the vSphere object. We can create, configure, provision, and delete the vSphere object. So think everything that whatever guest operating systems we have on top of host or maybe cluster of host, everything can be managed from one application, and that application is nothing but vSphere web client. So vSphere web client, it's very popular in terms of vSphere client. So we are not telling okay vSphere web client, but vSphere client. From vSphere client we are going to manage, monitor, organize, check the health, and there are so many things. Plus we have so many added new application. From there we can actually go and add certain new capabilities inside this management plane, inside this management web application. Correct? So once you log in, how it look like, here you can see that this is the navigation tree or the navigator. Then the second is the main content area. So what's the inventory list, host cluster, VM, storage, networking, content libraries, we realize orchestrator. So many things we can go and check from here. Then on top you have the search bar. Now my login will be a little bit different because again we are using some new or the latest version of vSphere client. But more or less you can see that you have work in progress, you have alarm, you have recent task, etc. It will look like that. You can go to the home button where you will get the list of all those objects or all those operations that you want to check. Once you click the global inventory list, it will give you the inventory list related to data center, host, cluster, network, storage, virtual network. So all the objects associated with these variants or these operations you will get from the global inventory list. Likewise, I can go to the home. From there I can go to virtual machine. I can go and log to a individual virtual machine. I can go and check their summary, their hardware, their capabilities. You can see I can go and check their hardware things. If I want to add any new vNIC or the NIC card, I can go. You can see 1, 2, 3, all these things I will show you in the lab as well. So I can go click and I can add one new NIC. Once you add a new NIC, what will happen that you will find that that particular NIC, once you add, you can see the work inside the recent task and the progress also you can go and see. So work in progress, all those things you can go and verify. So let me quickly log into the vSphere client and let me walk you through all those things that just now we have seen. Alright, so I logged in inside the vSphere client, and here you can see the task, the navigation, the task here, the main content page, the navigation, the search, all those things. The home button also here in the menu is little bit different than what we have seen, but more or less is the same thing. Now what I can do, I can go click to the menu, I can go to the inventory list. Here you can see the objects related to a resource related to data center, host, cluster, resource pool, data stores, data store cluster, network, virtual distributed switch or port groups, etc. All those things we have here. Here I have the task and the alarm also. So you can see the task, I can see the alarm. And alright, so what I'll do, I'll go to the host. Once I am inside the host, actually I want to go inside the virtual machine. So let me go like this. You have multiple ways. You can click to the menu, you can click VM template, you can reach here, or you can click here you can go to the global inventory list. Once you are inside the global inventory list, you can see your hosts are there. Once you are inside the host, likewise you can go one by one. Inside host also virtual machine, I can go here. I have the tiny URL. I can go back. That's the power we have with this management. I can tell this is the management plane, or I can tell that this is the management web client URL from where we are going to manage, or from where we are going to give the instruction to all the objects inside the VMware data center. Think like this is a data center. We are managing a data center from a web application. All right, so I want to go to the this Windows client, and let's see what is here inside this particular hypervisor. Remember, when I'm going to global inventory, host is nothing but the hypervisor. Inside this hypervisor, I have the guest operating system. So how many guest operating system you have? You have two guest operating system, Tiny Linux and the Windows. I want to go inside the Windows. Once you are inside the Windows, you can go and click here. You can have the summary. These are the hardwares. I want to add one of the hardware here. So I can go click edit setting. Once we are inside the edit setting, I want to add one network adapter. So let's add one of the network adapter. And here I'm not getting the network adapter in the bottom, but here you can see on top you have the add new device. So this is actually a little bit newer display we have. So you can go click add new device. What you want to add? You want to add the network adapter. Once you click add network adapter, you can see the new adapter option came up. I want to select that. What is your network? So it is asking about which particular distributed switch, and let's add this one. Once I add this, and this is showing the connected as well. Connected on power on, yep. And then what we'll do, simply click OK. And if you click the recent task, here you can see that task is on. Let me show you this 6 millisecond, and this is related to Windows. This is the way that you can actually go and see the recent task. So task is going on with the Windows 10. We have added one of the NIC card. Task is completed. So let me quickly do one more thing. Let me do one more time so you can understand. Add new device. Add one more network adapter. And VM reason 1, something like that will add. So I will go here and I'll click browse. VM reason 1. Okay. And see the task queued, completed. Have you seen that? It was queued and now it is completed. So now we have the 2 tasks. Here you can see in the taskbar. So this is the way that see how easily we have added one of the hardware component, one of the networking component. Like that, it's very easy. Just with help of few clicks, you can manage, operate, check the health. You can do each and everything from this particular vSphere client. Server virtualization feature. What features we have when we are doing the virtualization, and we have tons of features and the availability and the capability enhancement while we are using the virtualization. So what are the main features we have here? You can see that we have virtual machine high availability. We'll see one by one all these features, but you have high availability in terms of virtual machine. You can do the VM motion, virtual machine live migration. So that's the vMotion feature. We have the resource load balancing feature. We have the virtual machine fault tolerant feature. One by one, we are going to see all these things. So for example, you can see, suppose you have 3 hosts, host 1, 2 and 3, and I am referring at the moment ESXi host. Now on all the hosts you can see that VMs are hosted or installed, but suppose if one of your host is down, what will happen? With high availability feature, these VMs, they will get migrated to the other host. So guest operating system will be migrated without any issue to the other host. That's the high availability feature. Now suppose you want to migrate certain VM from one data center to other data center, or from one ESXi or host to other ESXi and host, you can migrate it and they can have their original state. So it's something like a term known as the stateful migration. So whatever state they have inside one of the host, once you migrate it, still they have those state. And here you can see that they are attached with the shared storage. So obviously here also they have the same data stored. That's the second feature, that we can do the live migration without much interruptions. How we can do the live migration and all. It's very easy. So which particular host is, which particular VM, so suppose VM that I want to migrate, it is attached with host 1. What you can do here, that simply you can do, go to the VM, right click, use the migrate option, and then you can attach to host number 2. So now new VM will move to host number 2. Very easy to migrate, no much issue in that. Then we have the resource load balancing. Here you can see that if the load on one of the host is peaking and you have some marker set there, oh, more than 95% or more than 90%, then move that VM where the load is less. So now you can see after the resource load balancing, all the hosts having the 60% of the resource utilization. Then we have the fault tolerance. Suppose one of your VM is getting crashed, so what will happen? Automatically the VM will go and install to the other hypervisor. Obviously, when you are using such type of strategy to provide high availability, at that time you have to reserve some resources inside the ESXi or host. That is there, but think about the high available server, or the server who is hosting very high available applications. So in that case, you don't want to lose that the customers or client will lose access to those applications. So rather, we can provide redundant host to one host, and we can provide some more resources. Obviously, that is cost effective, but still we are getting the high availability. Correct? Now again you can see that we have the disaster recovery. So in case of VM, when I'm replicating one VM, then other, means suppose if application got crashed, operating system got crashed. In case of physical server, you unbox one box, then do the installation for operating system and then install the application on top. It's time consuming, but in case of VM, it is like very easy, that you can install new server and application and it will work very fastly. Then we have the better use of the data store, and we have thick and thin provisioning type of provisioning. We'll see later on that while you are doing the installation of the operating system over the data store or over the storage, at that time we have multiple options. So suppose if I want to save the data store or the storage space, at that time I can use the thin provisioning of the VM, and drastically it will improve the storage efficiency, or it will reduce the storage cost. So here you can see that it's high available, it's cost effective, it's fault tolerant. So many things we have once we are using the virtualization. Again, you can see in terms of cost. So suppose if we have 10 server, and those servers, because those servers are not using all of their hardware capabilities, they are underutilized, they are using only 8% of the bandwidth utilization or resource utilization more precisely. At that time, for one server the cost is $4,000. Overall the cost is $40,000 or 40K. But suppose all those application you are using only 3 servers, and then you are using the efficient use of the resources or the hardware resources of the server. At that time your cost is only 12K. You can easily save 28K cost, and this is just 10 server. In production you may have thousands or 2000s of servers, or maybe more than that. Correct? So you can think how much money a company can save while using the virtualization. The other interesting features we have the power management. So suppose if the VMs, they are not actually used by any means they are not actively transferring the data at that time, my software will automatically uh, put those devices in sleep mode. So obviously they will not utilize the power if they are not in use. So like that we have the mechanism. They will put in those devices in the standby mode or sleep mode. Then the maintenance mode. Uh, this you can see in the roadway construction as well. So whenever some repair work is going on the roadside, they are putting one logo, one banner there that see this road is under construction. So what does it mean? Means still people are using that road, but they are not using for actual traffic. Means still some of the traffic is going over there, and that's a very important thing, or traffic that can go, but still it is in maintenance mode. So either wait till maintenance period, or if you are using, still use very less capacity or capability of that particular at that particular time. So that's the maintenance mode. You can put them in the maintenance mode. At that time the resources will not get utilized, and other work can be done. So for example, in upgradation of the software, or putting some patches, or any other security patches, etc. So those things can be done in the maintenance mode. Then we have the snapshot. Here I have highlighted the snapshot is nothing but a copy of the VM file with a reference of that point of time. So you have one copy. Whenever you take the snapshot, so you put certain marker. You can think like this, that you read 1000 page book, and then you put a small marker there, like okay, you read up to, say for example, 120 pages, and next time whenever you start, you will start from there. It's something like that. You can have a snapshot of that particular instance. So the VM, next time if you start that VM will start from that particular point, rather than it will start from 0. Then we have the cloning and the template feature. Cloning means simply you can clone the VM, and we can see this in our lab, that how you can create the cloning. But the problem with the cloning is that you are cloning only one particular VM. The more generic term or generalized term is the templates. So you can create one master copy, that is nothing but the template, and then you can reuse the template to install or instantiate other VMs. Correct? So you have one master copy as a VM, do some modification, and then you can install the other VMs. So if you add all these features, you can see with help of virtualization, not only that you are reducing the cost, but you are making this high available. Say disaster recover, you can create snapshots, you can create template. So template may be to do the generalization of the configuration, or you have the master copy from where you can do the cloning, or you can install the devices. So you have so many added advantages and feature once you are using the virtualization. And more precisely, in this point of time, we are talking about the VMware virtualization. In this section, we are going to install one virtual machine over ESXi. You can see the steps. You can go to the home, click VM and templates, then go to the data center. From there, in the bottom, you can go and select create new virtual machine. Then you will get one page where you have to follow the steps one by one. So you have to go and check that select a creation type. It's a new virtual machine, or deploy from template, cloning, etc. Then you can go and check the name and the folder what's the compute, what's the storage. So let me show you one by one all these things. So I'll go and give the web server 01 as a name, select which is the data center belongs to. Then you can go and give what's the compute. Say for example, this is belonging to ESXi 1 or 2 or 3. Then I can go and give the data store, say DSIS SCSI. Then a few of the other things that the check and the compatibility, etc. Once you do up to this step, then finally you have to go, and here you can see some of the slides are overlapping. So from here, from point number 2C, you can go here and see 2C. For example, I'll select this DSIS01, and then in my case, my ESXi is 6.7, so I can go and select that. Then I'm going to use the same guest OS and the guest OS version. Once I do that, then I'll go and select the new CD and DVD drive as well. And then all the steps you can see 1, 2, 3, 4, 5. Once I do ready and complete, finish, that's it. Then once my web server will be showing there, what I will do right click and then I'll power on. So let me do one thing. Let me quickly log into the ESXi or the vSphere client, and from there I'll show you that how you can follow all these steps one by one. So let me quickly log in there. Alright, so I logged in inside my vSphere client. I can go to the menu, and here you can see VM and templates. Here also you can see the VM and templates. We have the shortcut key as well, Control Alt plus 3. Once you are here inside the client, if you go and click to the data center, and let me scroll down, let me expand this first, and here if I do right click here, you can see you have option to create add host, means you want to add new ESXi, you want to add new cluster, you want to create new folder, you want to create distributed switch. Later on we'll discuss about this. You want to create new virtual machine, or you have the OVF template. So here we want to create new virtual machine, and now you can see all the list and questionnaire we have. So create a new virtual machine. Yes, I want to create this. What's the name? So let's go here and give the name, say for example web server. So I'll give name as a server 01. What's the location? Here you can see I can go and check the location. That is nothing, the site A data center. Next it is asking about the compute. I have a 1A and 2A. I will select 1A for the moment. Then there's storage. Now I'll select the first one, that is the ISK01, and on top you can see that we have option data store default, vSAN and vVol, no requirement policy. So we'll leave this as default. We'll go next, and then the compatible 6.7, and later we'll use 6.7 at the moment. We'll go and click next. Now select a guest operating system. What type of operating system this is? This is a Linux, and I want to use OS 64-bit. So this is the family, this is the version, correct? We'll go next. Now the customized hardware, it is asking me that this is the hardware details. You have the CPU, 1 core, memory 2 GB, new hard disk 16 GB, iSCSI controller, new network connected. Here I want to add this new CD drive, DVD drive. I want to add this, say for example, data store ISO. So suppose if I add this, it is coming here, it is asking that what image you have inside the data store. You can see that you have Tiny, Linux, etc. In NFS, what images you have. In VM image, what images you have, correct? So actually I'm looking for that photon image. So I'll do one thing, I'll do cancel here, and let me try to check what is there in the content library ISO. Inside content library ISO, you can see that I have photon 2.0, and I will save this, means I will select this and click OK. I'll make this as a connected, and rest of the options also you can see here.
You can go to VM option also, you can see all those options. So we are almost done with the installation of the VM, and let's click finish it. Once you click finish it, you can go and check the task as well. So here you can see the task is going on, and you can see that you have the VM server, web server 01 that is at the moment powered off, and you have this launch remote console as well for this server. But before that, what I'll do, I'll go here and I'll do power on for this server. Once I power on, I can go and click launch remote console just to see that how it is working behind the scene. So now you can see that the install option has came to install from the CD DVD that we have attached. So let's quickly go through it. All right, and now you can see that it is in progress. You accept this, yes, and then the virtual disk is 16 GB. Okay, I am just pressing enter. This will erase the disk. Are you sure? Yes. We'll wait for few seconds. I want to install this Photon minimal. Yes. Hypervisor optimize. Yes. And then it is asking about the host name. So I'll give the host name as a, for example, web server. So web server 01 is the host name, and then I should give the passwords. So let me give the password, a long password. Let me try to retype this password and confirm password. Now the installation is in progress. You can see all the installation steps is going on. Congratulations, Photon has been installed in 20 seconds. Press any key to continue to boot. So I'll go and press enter, and now it is booting up. We'll wait, and here it is. Alright, so here you can see that now I have the username and the password. So I'll go and give the username and the password that I have set earlier, and now we are in. So now we have the web server 01, and if I see the IP address, because it is connected with the DHCP, and if I know what's the outside IP address, so let me try to ping from here. Say the IP, I know the IP from the outside is 192.168.110.10, and this command is not found in this Photon. Now because we have done this minimum configuration, so that's why this ping by default is not installed. So let me try to install this ping feature, IP utils. Let me try to do that. Just in this case, what we have done, that we try to do the minimum installation, because our goal was to install a particular VM, and in the minimum install for the Photon, the ping was not supported. So I have used this tdnf install IP utils just to install this feature, and let me try now. Still the ping is not there. So never mind. What we can do, that we can do the full install, and in the full install this ping will work. So our task is done, that our installation is successful. Let me minimize this and let me show you here. So let me go out from here, and now you can see this is power on. We have launched the remote console as well to verify this, and now it is up and working. Alright, so we can stop here now. In this particular section, we are going to perform a task that, with help of cloning, how we can create the template. From that template, we are going to create one of the VM or virtual machine. So how you can do that? You can go to the home and you have the VM and templates.
You can actually select any of the VM, do right click, go to the clone and clone to template. That's a step, clone to template. Now once you go to clone to template, then you will get this menu, A, B, C, like all those options. So what's the name, what's the compute, what's the storage, like that. So you can go and select all these things one by one. Once we have the template created, now from this particular template, I want to create one VM. So now here you can see that I can deploy a new virtual machine, and then this particular virtual machine is using this particular template, correct? So let me log into the vSphere client and I'll show you all these steps one by one. Alright, so we are inside the vSphere client. Now what you can do here, you can go to the home and you have VM and template. Now, for example, I want to create clone with this tiny Linux. So here you can see right click, clone, clone to template. Clone to virtual machine means you are creating only one instance of that particular virtual machine. Now what I can do here, I can give the name, say tiny Linux template. Like that you can give any logical name. Once you do that, then you can go next. So we have point 1, 2, 3. I can go and select the compute. Otherwise by default it will take the compute. Then what I want, select the virtual disk format. I want to use this thin provisioning. So this will be lightweight. I can use the storage. You can select the storage. We can go next and then ready to complete. Now we'll see that in the task, if I go and click the task, we'll see that task is now 100% and we have this template called tiny Linux template. Now from this, I want to create one of the VM. So if I do right click here, you can see that new VM from this template. You can see how easy this is. Simply I have to go and click and right click and select the option. So I'll give the name as a, say for example, app server 01 this time, and we'll go and click next. What's the compute where you want to put this? Say for example on the host 2, ESXi2, I can use this ESXi. This storage is DSI SCSI because this 12 GB is free, so I can use that. Now here you can see we have option for the clone, customize the operating system, customize the virtual machine hardware, power on virtual machine after creation. If you want to customize the operating system, you can use it. If I uncheck this, you can see you don't have this option for the customized guest operating system. So what I have done, that although this is the template and it can use whatever operating system was there in the parent template, but here we are getting option while using this template. Everything will be used as it is like the old template, but we'll get the operating system option. Even if I choose this, I'll get the options related to select the hardware. So let's do that. We'll do that, no problem. Now customize the operating system. Here you can see that you can use the operating system that is other Linux 32, and here we don't have any option, so no problem. We'll go next. We'll see the hardware, and in the hardware, if you want to attach certain disk from the library, you can go and attach. So for example, I'll use this Photon that we have used last time. So I have attached this. I'll click connected as well. Then I can go next. Now here you have the summary. Now only problem that we have maybe we'll get is the customized guest operating system, but let's see. So once I've done that, my app server 1 is there. You can see that it's up and running. Now if I go here and click launch the remote console, let's see. So it has launched, and this is actually the tiny Linux. So whatever properties that you have with the tiny Linux, the same type of properties you will get here. But obviously we have the hardware customization option where we can go and change all these things. So if I do the Linux based command like if config, and I can see that it has IP 192.168.120.51. So let me try to ping from here 120 dot or that's outside IP is actually 110.10. So if I have routing, and can see that the routing is there towards the outside gateway and it is able to ping. So now you can see that this is the way that we can go and how easily within 2-3 minutes we can go and one of my app servers up and running. Here you can see the IP is 192.168.120.51, and here also the IP is the same. That's the thing that you need to consider. So you have to go here, you have to do certain changes in the network, and then your IPs will be different. But most of the things will be same because we have used a parent template, and from that parent template we have different instances of virtual machine, and these are the exact steps that you can follow to create the VMs. Alright, so let's stop here. Let us continue the last section. In last section, we have studied how to create the template, and from that template, we have deployed the VM. We have a nice tool called search, and I'll show you that search option as well. But in the last section, we have done some changes. So let me first show you those changes, and then we'll check the search option. So let me log into the vSphere client. Alright, so I logged in inside that, and once I log in here, you can see that we have created app server 1 whose guest operating system was 3.x Linux 32-bit. And if I go and show you the properties, what we can do here, I can right click here and I can go to edit setting. Once you are there, we have taken this content library ISO function that is connected as a photon, but this is not the exact operating system we have. The exact operating system is, the guest operating system is 3.x Linux. Suppose if you want to reboot it and try to run this, so let me do power on, and I'm powering on this. What I want to do here, that this particular VM, I want to reboot and try to check, means after reboot I want to just check it that it is operated via the CD DVD that we have connected. But if you do that also, you'll find that still it will take the operating system as a guest operating system, that is nothing but the Linux 32-bit other 3.x. So what I can do here, I just want to replicate one of the VM that is related to Photon that we have created in the previous section. So let me do this thing. I want to create one more template now. I'll go to this tiny Linux 2 that we have created. This was the web server. Yep, this was the server that we have created earlier, but what we have done, that we have taken the minimum OS installation, and some of the features like ping and others are not supported. So what I'll do here, I'll go back here and I'll clone this as a template. So let's go to the clone to template, and I'll give this name as a, for example, web server template, because we are creating the template. We'll go next and let's see the compute. So I'll use, say, for example, 2A just to balance the load. And I have insufficient disk now, so I can see that disk space is less. What we'll do the thin provisioning, and we can see that disk space is less. So let me do one thing. Let me quickly go and delete few of the VMs that we have installed. So let me do this thing. I'll go here, right click, and I want to delete this. So here you can see that delete from disk. Yes, because I want some more space that I don't have. Even I am not using this guy template, so I can go and delete this also. Now even the deletion also, you can see that how easy and straightforward. Now let's go here and clone to template, and again we'll give the name as a web server template. Once we have that, let's go next and see this time the compute. So for example 1A, and I can use any of them. Disk space is less, it is showing, and that's the problem we have now. In this particular lab section, you can see I have very less disk space, and this is using a storage as 18 GB, and this is using just in MB. So while doing this deployment, I should limit the space as well. So if I go here and power off this, let's try to limit the storage space. And then if you go to the settings, hard disk, you can see it's 16 GB that I can make as a 4. Let me try to make some other number, 10. Let's see how much space is required. It is showing the error. Enter the disk capacity which is larger than the original capacity. So I can't give less than 16, but if I give 17 or 18, it will take. I can do one thing. I'll disconnect this drive first, and let me give this 16. So while doing this this type of lab, you should check the storage type and all. Otherwise, again, later it will be difficult to create that. So meanwhile, what I can do now, that anyways I don't want to create the template from this, I'll create one template from tiny URL itself. So I'll do one thing, I'll go and delete this also from the disk. Yes. And the same steps I just wanted to show you. Clone to template, and this time I want to do the full configuration. What type of template is this? This is, say for example, web server template, and these are the issues we can get around. So it's very important while doing the installation and all, we should do the proper planning. Otherwise, it will throw repeated errors. So now if I click here recent task, you can see that it is working on, and once I have this server template, then I can go and convert to virtual machine. New VM from this template. So all the options we have, but actually I'm looking for this particular option. This is web server, for example 002. We'll go click next. The compute, I'll leave this as default. Okay, so for example 2, and the first one, if I check both the places, I have the options. So I'm not using, now you can see that I'm not using any of these options, and then we are finished. So once I am finished, here you have this, and this guy also have the Linux 3.2. So who has the Linux. So everyone seems having the operating system 3.2. Alright, so this also has the Linux 3.2. Now I don't want to create any other thing. I just wanted to show you that I have one name called Tiny, one web, one Windows, and Tiny, etc. I can go here to the search, and suppose if you have hundreds of VM machine and you want to search a particular one, you can go and use the extensive search method. So it will go and search for you, and that is one of the nice trick we have. So I can go to web, I can go search Tiny, etc. And directly you can go and search that particular VM from anywhere. It's not like we are inside the VM and we are searching. From anywhere you can go and you can search to the specific system. Alright, so this is the way that you can go and search. You can go and delete also. We have seen that how we can delete. You can go and do certain changes in the hardware parameters as well. These are the options we have from this particular management dashboard or the vSphere client. Alright, so let's stop here. In upcoming few videos, we are going to learn about vSphere availability and the distributed or dynamic resource scheduler. So let's start this. Now you have different bullet point here. You can see what is happening actually, that whenever you go and enable the vSphere high availability or vSphere availability, at that time different host. So suppose if you have 4 hosts in a cluster, so they are part of cluster, they will elect some sort of master and slave. And in the upcoming slide, we'll see that how they are going to elect master and slave. So they will elect master and slave, and the master have the list of all the VMs and the resources. If any of the VM will got crashed or any of the host will got crashed, then it's the responsibility of master that he will put that VM to the other host, or put that guest operating system to the other host operating system or other host. Let me read all these points one by one, although these points are quite big, but let's see that. So what is happening that to enable this high availability or all the hosts that at least select their master and slave, you need to go and enable the high availability. Okay, so once you enable that, what is happening that virtual machines, by polling the virtual machine and the host they reside into cluster, means you have one master, he will start creating the list for all the other devices, all the other hosts and the VMs in a cluster. Okay, great. Then hosts in the cluster are monitored, and in the event of failure, the virtual machines on the failed host are restarted on the alternate host. It's very straightforward. So suppose you have 2 hosts, and if it is crashed, the master, suppose this is the master one, so it will take that host on him, both the host on him. So this is the point number 2, is something like high availability, or if any fault is there, fault prevention, something like that we can think. Alright, then when you create a vSphere availability, we need to go and create this. A single point is automatically elected, a single host is automatically elected as a master host. We'll see that, what is the agent behind that in the upcoming slide. The master host communicates with the vSphere server and monitor the state of all protected virtual machines and of the slave host. Very straightforward, all these points. So you have one master, he will detect, he will monitor all the host, all the slave host, plus all the protected VM. And once he will be elected as a master, then his responsibility to do the resource allocation. Correct? So this is actually summary of point 1, 2, and 3. Then different type of host failures are possible, and the master host must detect the appropriate deal with the failure. The master host must distinguish between a failed host and one that is network partitions or become the network isolated. So say you may have different type of failure. So suppose if this link is down, suppose the management network is down, suppose one VM is down. So everything that master responsibility is to detect and provide the solution. So you could think that someone is the management in your uh, election process, and that management or the higher authority, who has the higher authority as a master has the higher authority to elect or to take the action in case of failures. Okay, so master host uses network and the data store heartbeat to determine the type of failure. Also note that the vSphere availability is a host function, which means there is no dependency on the v center in order to effectively fail over the VMs. So it's purely, this particular rule is purely based on host, not it's the responsibility of vCenter software. Let me show you the diagram. So here you can see now little bit clear and clean diagram we have. So you have host 1, 2, 3 and 4. One of them has been chosen as a master. How? So what is happening that you have something called fault domain manager, one small agent running on all, and they will internally elect that who is the master. So once you enable the high availability, one of them will become the master and his responsibility to monitor all the protected VMs and the host. Correct? Now, master role. So here you can see that who is the master role here in this diagram. This is the master. ESXi host and virtual machine availability. So what master is doing? What fault domain manager master is doing. So he is checking ESXi host and the virtual machine availability. All slave host upon slave host failure, protected VMs on the host will be restarted. So suppose this is down, all the VM hosted will be placed here and here, and again he will track that. The power state of all protected VM upon failure of a protected VM, the master will be restarted. So you can see that he has the authority. Any failure, he will restart that VM and it will be placed to the other host. Now, the master manages what they are managed. They manage the list of hosts that are member of the cluster, updating the list of hosts. So it has the list. So if suppose if you are adding more and more hosts, he will update. If you are deleting also number of hosts, he will update his database. So think like that he is the data server or is the database server who is maintaining all the host and the VM, a protected VM inventory. Correct? The list of protected VM, the master updates the list. So he is updating the list of VM, that is the protected VM, the host as well. Now what's the role of the slave then? So these are the slave at the moment in our diagram. What they are doing, a slave monitors the runtime state of its locally running VM and forwards any significant state change. So they are maintaining their local VM. If any change is there, they have to consult the master. Hey master, there is change. So you have to update your database. It implements a vSphere HA feature that do not require central coordination, most notably HA health monitoring. So we will see that we have the HA VM health monitoring, and they are the part of the health monitoring, and we have various options as well. So we'll log into the vSphere client in the next section, and I'll show you all those options. It monitors the health of the master if the master is failed. So suppose if master is failed, again they have to rerun the election process and they have to elect who is the master. Maintain list of power VM. So whatever power down VM they have, they are maintaining that. Now in which case the master election happens, when we are going to enable the HA first. If master is failed due to any issue, they will re-elect the master. If the management network partition occurs, any issue with the management network, then the master election occurs. How we can go and enable that? You have to go inside the host and cluster, go to action, go to settings. Once you are in the setting, you have option here to enable the vSphere DRS and vSphere availability. We'll click vSphere availability, go to the edit, turn on the HA. Once you turn on the HA here, you can see that you have long list of options like failure responses, proactive HA failure responses, admission control, heartbeat data store, advanced options. So we have the option. In the next section we'll see that what are the options these are doing, and we will select one option. So for example, when you are inside the admission control here, you can see that you can configure how vSphere HA respond to the failure condition. The following fail host is isolation, VM component protection, data stored with PDL and ADP. So PDL is nothing but permanent device loss. APD is nothing but all path down VM application, and then you have these options. So in the next section, I will log into the vSphere client, and one by one, I will show you all these options. So let's stop here, and next section, we'll log in and we'll enable the HA from our vSphere client. Let us perform the HA lab. So here I am in the main dashboard. What I can do that I can go and click to the host and cluster. Once you are inside the host and cluster, you can see here you have the action. You can drop down this action, go to the settings. Once you are in the settings, you can see you have the vSphere DRS and you have vSphere availability. vSphere HA is turned off. Proactive HA is turned off. So I'll go here and enable this HA. Click edit. Once you are clicking edit, you can see that you have the same thing that we have seen inside our notes. I'll go and enable this vSphere HA first, and then you can see the options. So what are the options? Host failure response, restart the VM, disable. So we'll use this restart the VM, and here you can see that if you go and expand this, what does it mean? Restart VM. Restarted VM means when a host failure is detected, VM will be restarted in the other in the order determined by their restart priority. So this is the actually a method what will happen in case of host failure. Now we can see that you have the response for host isolation. We'll leave this as a default. Data store with PDL, that is a permanent device loss. And although you have multiple options, like you have issue events, you have power off and restart VM. So all affected VM will be terminated, and the vSphere HA will attempt to restart the VM on host that is still has connected to the data store. It depends that what's the business requirement, what type of a rule you have for the permanent device loss. Then you have the data store with all path down. If all path is down, power off and restart VM. Conservative restart policy. If I scroll down, you can see you have these many options. Power off and restart VM, aggressive restart policy, conservative restart policy, issue event. So you can see that now we are going beyond whatever we are started this course means as a basic. So we are going beyond the basic, but you have multiple options. The bottom line is this, that we are doing the virtualization with help of one of the highest demanding product, that is the VMware virtualization, vSphere. Most of the companies, they are using this to use or to automate or to virtualize their data centers, virtualize their virtual machine, and monitor and track their virtual machines. And then once we are doing this whole process, once we are doing this whole activity, at that time to provide high availability, to provide fault tolerance, to provide business meaning. So meaning to the businesses means high availability and scalability, etc. We should have all the options that we are seeing here. So at the moment we are seeing the HA with the host, and that is connected with the VM that is hosted over the host. correct? And then finally you have the VM monitoring. So you can see the enable heartbeat monitoring. VM monitoring reset individual VM if their VMware tools heartbeats are not received with the set available set time. So how my host knows that the VMs are hosted on that? That means the host and the VM behind the scene, they are sending some keep alive message that we used to see in our Cisco networking world. So they are sending some sort of heartbeat message, and I will enable this VM and application monitoring. Okay. Even I have clicked OK, but I should go and use all the options. So we have done this first option, failure and responses. Then we have the admission control. Admission control is a policy used by the HA to ensure failover capacity within the cluster. Raising the number of potential host failure will increase the availability constraint and the capacity reserve. So we'll go here and we'll do this thing, cluster resource percentage. And performance degraded VM tolerate means what is the level of the tolerance you have. So although you are managing the HA availability, high availability, so in case of failure, how much percentage of the degradation you can tolerate is something like that. This toleration, how much you can tolerate, what is the percentage you want to tolerate. So once I use this option, I can leave this as a default. Even if you can go and override the calculated failover capacity with respect to percentage CPU and memory utilization, but at the moment I leave this as a default. Alright, but again these things need proper guideline that how much and what is the permissible limit that you want admission control. Then we have the heartbeat data store. What I want to do for heartbeat data store, that automatically select data store accessible from the host. But yeah, you can pause the recording and you can see what options you are getting. Okay. So just if you use this use data store from the specific list, in case of failure, the host will use which particular data store to connect with. This is the reason you have this heartbeat data stores. Alright, then finally we have the advanced options as well. I leave this advanced option as default, but you can check. You can go and check the this vSphere 6.7 configuration guides and the VMware knowledge base. You can check the other options as well. At the moment I'll leave it. So what is my setting as per our slides PPT? We use these settings and then we'll click OK. Alright, so let me click here the recent task and see that the reconfigure cluster 11 millisecond back, it happens. Once we have turned this on, then I can, let me scroll a little bit down so you can see all those options. Few of the options we have enabled, few of the options we haven't enabled. You can see here the admission control, reserve failure CPU capacity and memory by default, it is 50-50%. Then data store heartbeat, if I scroll down, that also you can see what option we have selected. Use data store for the specific list and the component automatically if needed. Advanced option, we haven't chosen anything. So what we can do here, we can go and click to the monitor, and inside monitor, if you go and check the HA, so here is the HA, and inside the HA we have the summary page. Inside the summary page, now you can see the summary related to, say for example, host. So who is the master? Clearly you can see that the ESX 02A become the master because we have two hosts and they have done their election process. One become master, host connected with master 1. You can see the list of things that he is checking. Then the virtual machine 1 protected. Great. And here you can see the cluster total memory, failover capacity memory, the CPU failover, all these manipulations we have. I can go and check the heartbeat. So you can see that one of the hosts is attached with the two of the data stores. Then we can go and check the configuration issue. There is no issue. CPU allocation, data store under APD and PDL, we haven't enabled that. So this is the HA. Once we enable that, we can go and check these configurations. Suppose if the data will not updated, what you can do here, you can go and refresh this and then it will update all the data. Next we have a distributed resource scheduler. Now what is the use of distributed resource scheduler is that whenever the VM is powered on, that particular VM will be placed upon the host. That's the first thing. Second thing is, suppose if the host, they are highly resource utilized, then that DRS, distributed resource scheduler, they will put the VM from the host to the other host. So what does it mean? Suppose I have two VM here and the overall resource utilization is more than 90% and they have, say for example, 30% and 30%. So the host may be moved from the VM, may be moved from this host to the other host. Say for example, host, this is host 1, this is 2, 3, to 2 and 3, correct? So that is the automatically movement in case of optimized resource utilization. And the first use is that once you power on any of the VM, those VM, the DRS will provide the host to those VMs. Alright, so that's the use of the DRS, how we can enable it. The same way we'll go and enable this. We have three methods. We are going to use the fully automated, but we have the manual, partially automated and fully automated methods related to DRS. Now let me go and log into the vSphere client and let's see how we can enable, and after enabling it, how we can see that. Alright, so we are here in the site A cluster. Again, I can go to the action. Once I am inside the action, I can go to the settings. Once we are inside the setting, you can see the vSphere DRS. What I want to do, DRS is turned on actually, but it should not be turned on. I can go and turn it on, so it will be like off. You can go and turn it on. Then the automation level, I want to give automation level fully automated, and the conversation and the aggressive. So conservative and aggressive, you have this slider, you can move this slider towards conservative and the aggressive. So I'll move this in between. Then you have the predictive DRS, then you have the virtual machine automation that is enabled, and that's the thing we are looking for. Click OK, and now what we can do here, we can go to the monitor. Once you are inside the monitor, you can go and check this vSphere DRS. Run DRS now. So I just click this to run, and I'll go and refresh as well. Then you can go and check the faults, you can go and check the history, you can go and check the CPU utilization. You have the network memory, you have the network utilization. You can go and check the task as well, 7 seconds, 7 milliseconds, 6 milliseconds. So that's good. I don't have any alarm. Let me put this down. Alright, so this is the way that we can enable it, and after the enablement we can go and check this. So at the moment we don't have any failure, so it will not show you anything. But yeah, in case of failure, in case of say heavy utilization of the host, it will automatically shift the VM from one place to other place if TRS is enabled. And in case of failures, we have the HA enabled. So we went on, we enabled both the HA, and we went on, we have enabled both the DRS. So you can see behind the scene how the capability and the features we have from the VMware, and more precisely from the vSphere server, and how we can manage the uh, resources with help of our vSphere client. So client is helping to manage the vSphere software, and with help of vSphere software we are managing the entire hypervisor, the virtualization framework. Inside that we have the host and the virtual machines. Everything will be managed, monitored. So here clearly you can see in the monitor I can have the issues and alarm. I can manage the performance. I have the task and event. I can have the distributed resource scheduler. I have the high availability for vSphere. I can have the resource allocation. So everything you can see that we have here, all these things we can monitor, we can configure, we can alter. Alright, so let's stop here. Let us learn that how we can monitor the performance inside the vSphere client or with help of vSphere client. Now we have all these options to monitor the health, network, CPU, memory, and n number of things from the vSphere client. But still, if we want advanced look for monitoring and performance, we have VMware other tool, that is the vRealize, and you can check inside the vRealize operational labs. So vRealize is one of the software. Once I log into the vSphere client, at that time I'll show you that where you can find this vRealize. But yeah, that's the other tool we have. Alright, so let's see what are the things we have. I can go to any of the host and then performance and monitor, or monitor and performance, and we can go and check the CPU chart. If you want, you can have the option, you can check the real time. So we have multiple option. We can go back in time like 1 day, 1 month, 1 year, real time, all those options we have. If you want to check the individual virtual machine CPU and the performance monitoring, we can go to the individual virtual machine as well. We can go and check that as well. Now the display that you are seeing here, it has been changed little bit in 6.7 vSphere. So when I log into the vSphere client, you will find little bit of differences, but most of the tabs are almost the same. So here you can see the percentage and the time slot, and we have various VMs. So I will log in and I'll show you all those things. Now suppose if you want to do the VM migration, you can go and disable this DRS. Once you turn off, you can go and do the VM migration as well. It's very easy. Simply go do right click and you can migrate from one host to other host, a particular VM. Once you migrate, again you can go and turn on the system. If you want, turn off, turn on. Now these slides is showing that suppose if you want to turn on or off a certain VM, you can select that VM. On top you have this green button, something like play button. You can click and it will turn on or off. It's up to you. Even you can do right click, you can go to power and you can do the turn off and on. So those options are there. If we are here at the vSphere, if we are here at the host level, there we have the reset button, and once we do the reset button related to VM, so if you want to turn off or on different type of VMs, so those options we have. I'll show you all those options. If you want to restart, yes, you can restart. If you want to do manual restart of certain virtual machine, so those options you have. Again, you can go and do the performance monitoring. So all these things that we are seeing here, I will log into the vSphere client and I will show you. While you are seeing the chart, by default it will be the line graph. Then you have the option for a stacked graph and a stacked graph per VM. So you can go and you can select the objects and you can do basically everything. So it will be much more clear when I log into the device and when I show you all these things. Now, if you want to export certain report, you have various options. Even we'll see that we have more option in 6.7. Here it is showing PNG, JPEG, and CSV. We'll see that we have much more option, few more options. And then likewise, you can check the CPU, you can check the cluster, data store, disk, memory, network, all these reports you can go and check one by one. We can go and check the memory and the real time the status. And then finally, once you done the VM migration, you can go back and if you want, you can turn on the DRS. So that's the whole uh, walkthrough that you are seeing here. And in the next section, next recording, what I will do, I will log into the vSphere client and I will show you all these steps that whatever we are seeing here, plus a few more options also you will see because we're going to perform the task inside 6.7. So you will see much more options and clear diagram, clear reports, all the visual reports you will see. It's very much clear in 6.7. And if you want to check more about the reports and the results and the performance monitoring, then you can go and check the vRealize. So let's just stop here. Next section, I'll log into the vSphere client and we'll perform the task. Alright, so let's perform the task. Now, once you log into the vSphere client, here you can see that you have vRealized operations. vRealize operation is not present at the moment. We need to install it, but what it can do, application aware monitoring is across SDDC and multiple clouds, automated and proactive workload management, cloud planning, capacity optimization, and compliance. You can click here, you can check all the use cases. It will redirect to website and it will show you that. So at the moment I'm not interested, but you can go and check. It's it's one of the nice product from VMware. So let's go and check our performance monitoring task. I can go to the host. Here you can see the host, and inside host it is telling that okay, what virtual machine you have, what VM template you have inside the VM. But what I want to go inside the monitor and performance. So once we are inside the performance, we can see the overall dashboard. Inside this dashboard, it's telling what the CPU, what's the memory, what the memory rate, what's the disk, what's the network utilization, all the utilization. This is just an overview, correct? Now what I can do here, that I can click here in the view option. You can see view overview, network adapters. Then you can go and check disk, virtual machines. So over this particular host, you can see the virtual machines. So you have the tiny1, tiny Linux memory. I think we have only one virtual machine here. So if I go ahead and check how many VMs I have over ESXi, only one. What I can do, I can go to the other host, and inside other host I can go and performance and the overview. And then inside overview, this is first of all the dashboard, the overview, and you can see how clear and nice it is. It is telling all these things as an overview in the real time, but you have last day, week, month, year, and you can select the interval as well. So you can go and select the timeline as well. Now if I go and select virtual machine, now you can see this tiny and the windows, one of the VM color. The Windows is using much more CPU and the memory, so you can see clearly here. This is just an overview. Inside performance, I have two options, overview and advanced. I can go inside the advanced. Once I'm inside the advanced, you can clearly see here that I have chart option. First of all, here also I have this options, last day, week, month, year, but I have the chart option. I'll go there. But if you want to open this particular page in new page, you can go and open. So here you can see that new page is coming. Here you can see the view in terms of data store, view in terms of memory, and view in terms of disk, network, a storage adapter, a storage path system, and the vSphere replication. Everything we are getting, and in the bottom you can see the legends as well. It is telling us all these information, and we have very nice graph, correct? Now here you have the chart option. If you click the chart option, even you are going much more detail. So suppose if I go and click CPU related options. So CU stop, core utilization, demand, idle, latency, swap, use, utilization. You can see you can select all these things, whatever you want. And then this belongs to the object, that is the host number 2, ESXi02. Here in this page itself, you can see the chart type. Now chart type, do you have a stacked graph? Do you have a stacked graph per VM? And when I'm talking about VM, you can see whatever VM hosted, it is showing. So either Windows 10, Tiny Linux, so you can go and check, select or unselect all these things. I can click OK. You can only select one distinct unit at a time for a stack graph. So we'll do one thing, that select only one. So we'll select the utilization percentage. Okay. And now you can see the stacked graph. This is for the host, the average utilization, latest, maximum, minimum, etc. But you can see how good this particular graph is. This is the performance chart over Google Chrome. We are getting it, correct? Wow, and it's a real time. So you can see that it is coming. All right, so let's close here this particular chart. And again, you can see here that you have export option, what options you have. So here you can see that you have options related to PNG, JPEG, SVG, and CSV. That's one more that we have seen in our slide. Great. So this is the advanced option. What more we need? We are getting all the reports related to all the available items inside the host. Now, what we can do, that we can go to a certain, say for example, VM as well. Once you are inside the certain VM, with that particular VM also, I can click performance and overview. So you can see the CPU memory chart. Same thing, say space utilization, network adapter, disk. I can go to the advanced option. Once I am inside the advanced, I have this chart option. I have the CPU option. You can see all these options. Basically what we are checking the power, network, memory, and CPU utilization. All right. So let me click to the chart option. And in this particular chart option, you can see the target object. I can choose Windows 10, and so for example, I want to see the memory. What is active memory? And you can see we have chosen the line graph, but again I can go here and I can show you the stacked graph as well. So here now you can see the stacked graph as well, correct? So how nice and how easy this is. Simply we can go and select, and now you can see it is showing some sort of error because maybe it has some memory issue, maybe it has some CPU high utilization issue. So that's why it is showing this error here. If I go to the events, and we are getting alarm, and what alarm it has. So let's see this particular alarm, that what it is telling. But yeah, it has certain issue here, and we can go and check the description. One second, let me try to open this. Alarm: virtual machine memory usage, Windows 10 changed green to yellow. There is no related event. And if I can scroll up, so you can clearly see that you have a certain memory issue, and if you want to open like in this format, you can see that this is again the XML format related to memory and utilization. Alright, so clearly you can see that we have issue with this particular Windows. They have some memory usage, correct? And even we can go and check in the performance and graph. But suppose if you want to filter this description and you want to see the event, and the date we'll see, the type I will remove. Just want to show you a little bit more space here. So if you have more space, you can go and check the Windows 10 related issue here. So what is happening? Virtual machine memory usage change from green to yellow, green to yellow, green to yellow. The full event you can see here. You can go to utilization as well, and you can go and check the utilization, but better that will go to the performance and you'll see the performance. You can see the memory, you can see the percentage in terms of CPU. So it is a spiking up, and even we can go to the advanced option and we can check the chart as well, say CPU utilization. You can see the CPU utilization. This is the real time. I can go and check the memory, and you can see the memory also. It's how much we have allocated and what's the memory. So suppose if I allocated 1 gig of memory, it is showing that as well. Alright, so this is the way that we can go and check the VMs as well. The other thing here, it was mentioned that you do the VM migration. So what I'll do for this, I will go and turn off the DRS first. I want to do the live migration of Windows 10. First of all, let's see that which particular host this belongs to. So you can go here and check the summary. It is belonging to ESXi02. You can see clearly the memory 1 GB 0.95 is used. So from the main dashboard also you are getting this thing, and here you have the option to acknowledge reset to green. So options are there, correct? So now I want to do the migration of this guy. I want to migrate. You can see you can go here and do the right click where you want to migrate, change compute resource only, change storage only, change both and compute and storage. So I'll do this. I want to select from 2 to 1. It has done the compatibility check and it is telling okay. You can change your compute. If I go back here just to show you that, here you can see that the destination network. So what's the source network, what's the destination network, that's the same. We have the advanced option as well. vMotion priority. Now you have the option schedule vMotion with high priority, that is recommended. Means vMotion receive higher CPU scheduling preference relative to the normal priority migrate. So I'm going to use the default. Ready to complete, yes. And now if I click this recent task here, you can see this percentage is increasing. Now from 0 to A, you will see that it become 0 1. So from 2 to 1 we have successfully done the migration, and now it is very much stable. Memory is still, it is using 0.96. It's okay, but what we can do now here, that again I can go to the monitor and I can check the overview. So memory utilization real time, you can see now it's not coming. It will come, it will take some time to generate that, so let him generate that. Otherwise I can go to the advanced and I can go and check the memory graph. Okay, so still it is generating, but I can see that now it is very much clean and green. So this is the way we can do the VM motion. You can see very easy, with few of the clicks we can do that. Now again I'll go to the settings, and because it was off, so I'll make this guy on, and you can go to the summary. You can go and check the DRS. It is imbalanced at the moment, is showing imbalanced. I can go here and check the HA because we have enabled the HA as well. So we can go and verify our DRS, and we can go and verify our HA as well. Nice and easy. You can see how easily we can do, but you can see how powerful this is. So many things that VMware has added, and now it is actually very efficient and a smart way to do the performance monitoring related to different attributes. Either it's a VM attributes or it's a host attribute. Alright, so let's stop here. This particular session is very important because we are going to start virtual machine networking, VM networking, and there are so many nice terms that we should learn and know. So let's start this. Now you can see that what's the problem we have. So once you have the host and once you have the hypervisor, so we know that we have the say for example host, and on top of that we have operating system or the guest operating system. So I have server, host, and the guest operating system. Now problem here is, so let me try to draw here. The problem here is that once you have host and you have operating a guest operating system, the first problem is that which software element should control the physical network adapter drive. So here you have your physical network adapter in the server. Who will control that? The hypervisor or the guest operating system? Obviously hypervisor has to control, but how? That's the first thing. The second thing, that how should communication occur between VM and the external resource. So now in this diagram you can see that you have your VMs and you have your server as well. Now these servers may be connected with switch, so for example L2 or L3 switch, and then you may have a router or you may have external world. So now this VM, how this VM will come, because this VM has their virtual NIC. So the virtual NIC adapter will come to the server and then it will go to the outside. Here we have the diagram. In this diagram you can see clearly that how these VMs will go and communicate to the outside. This is nothing but south to north or north-south traffic. So how this will happen? That's the second point, second challenge. The third challenge is that how the host will communicate to each other. So inside that I may have, so for example 25 VMs. So how this east to west traffic or east to west communication happen, and who has the control over this communication? Correct? So those are the questions. The solution that VMware came with in early 2000, that once you install this particular host, this particular hypervisor, at that time you have network standard switch. So you have host standard switch or vSphere standard switch, VSS. Now once you have the VSS, that means this particular VSS, obviously they have the VNIC from the vSwitch. You can think this as a switch in between. So now this is the switch, and then this switch will control the east to west or north to south or south to north traffic, etc. Now once we have this particular standard switch or the standard switch in terms of vSphere or network standard switch, we'll see the problem. Further, we have some problem. So before going to that particular problem, let's see this particular diagram here. So here clearly we'll see that you have your physical infrastructure, and if I try to analyze this with a switch, you think like you have one switch and here you have north. Just to analyze this particular diagram, here you have south, means here you have server, virtual server. So here you have virtual server, and here you have, for example, outside world, a router domain. Now we can think like this particular standard virtual switch or virtual standard switch, that in Cisco domain we used to study about access port. So access VLAN 10, access VLAN 20, access VLAN 30, access VLAN 40, etc. Then you have one interface that is going towards the router, that is nothing but trunk. So you can think at the moment this trunk is nothing but your uplink going toward the external router domain, and then you have this access port. These access ports belonging to certain VMs, you can think this as a port group. We'll learn about port group in the upcoming section, but you think this as a port group, and you may have certain specific port groups as well, certain specific VM port as well, that may be used for management traffic, that may be used for fault tolerance, that may be used for vMotion. So here you can see that the blue color is nothing but complete VM related ports, and there you have the uplink or your physical interfaces. So here you have port group related to management, port group related to vMotion, maybe port group related to fault tolerance, etc. Then you have port group related to test, port group related to production, and this is over one host. So this is nothing but host one, and same type of thing. That's a problem here. So if you want to scale up same type of port group with the same name, everything, you have to create across, say for example, if you have 25 hosts, 25 ESXi servers, then you have to go and create the same name throughout. And that's why we have evolved to the distributed virtual switch that we'll discuss later on. But yeah, here you can see the production, here you can see the test, the port group. So the attributes having common properties or common properties inside the same group, a group of common properties, anything you can tell, that's a port group. Then you have the vMotion, you have the management. So here you can see the uplink and you can see the downlink, or you can see the VM link. So this is nothing but my VM link, and this is nothing but my uplink. Everything is defined inside the port group. Common property, attribute group, or grouping of common property or common task things. So clearly you have, say, VM1, guest operating system 1, guest operating system 2, 3 and 4. 4 VMs. 2 of the VM they are part of, for example, sales. 2 of the VMs, for example, they are part of HR. So they belong to HR, they belongs to sales. Like that you can group the ports and you can connect with the virtual machines. Alright, so you can analyze like your normal Cisco world also like this, but again now at this time we should understand that virtually how they look like, correct? We should understand that those terms. Now what is the issue we have when we are using the standard switching system? In that you can see that the standard switch is created. So at the moment you will install ESXi, you have your VSS up and running. Now the problem here is each switch on every ESXi must be created and configured individual. So you have to go create, etc. This can be time consuming, although we can do some sort of automation, but it is taking some time to do this. The second thing, one important note when using vSphere standard switch and some of the high availability features with vCenter in the standard switch must be named. You have this naming convention. So your naming should be common throughout the vSphere domain. Okay, and then also note that the features like input out network IO control, LLDP network health check, and the backup and restore means some advanced features they are not supported in the standard switch. So these are the issues we have, and that's why we want to use the distributed virtual switch. We'll see in upcoming sections. In this important section, we are going to study about a VMware vSphere port group. That's the port group and the standard switch or the vSwitch. So what is port group and what is the significance of the port group? Now in this section, we'll understand 100% about the port group and the standard switch. Next section, we'll go and perform the lab task. So what is happening? I'll give you one example. Suppose you have one VM, virtual machine, and it has the VNIC. Now likewise you have other VM, say VM2, this is VM1 and VM2. This has VNIC. Now what you can do that these particular interfaces, virtual NIC, you can connect with a port group. Now again, what is the port group? So port group having common properties. Port group having common policies. So suppose if these VMs related to HR, so you can go and set common properties, common attributes inside the port group, And whenever you are associating different VMs to this particular port group, they are part of same port group. Okay. Now, one interesting thing, suppose if you know ACI, application centric infra, inside Cisco ACI, inside that we have concept of endpoint group, EPG. So suppose if you create VMM domain, and then if you go and create endpoint group, this endpoint group inside ACI is equal to port group as well. Now the concept of endpoint group is also same. You may have common EPG. So for example, EPG related to web or HR or sales, etc. Now those common EPGs, that means here uh, part of port group, or the port group is equivalent to endpoint group. Okay, so VMware port group and then Cisco has evaluated their endpoint group. Both are actually same. Common attribute, common properties. You can common properties interfaces, or interfaces that you are going to connect with the common properties. Those are nothing but the port group. Right. So what's the definition here? Let's see. So definition of vSwitch connectivity policy, which essentially define how the virtual device handle traffic that belongs to group of VM. In case of VMware vSphere, this policy is called as a port group. So you have one group where you are collecting all the ports, and this group having the policy that will be applicable to all the interfaces or all the ports connected inside this group, like that. Alright, so later I will log into the device and I'll show you how we can select or deselect the port group. With respect to this particular image that is here, you can see that I have, this is the vSwitch. I will log in and I'll show you all the properties in 6.7 vSphere client, and you will find the display is a bit different, but these policies or the properties will be the same. We'll see that in the upcoming recording. So they are belonging to, say for example, VLAN 105, then you have the security policy, traffic shaping, and the teaming. If I go back in the slide, so let me go back in the slide, here you can see that, let me go back one slide back. So here you can see that your vSwitch having security policy, traffic shaping, failover policies, and the VLAN tagged with that. We'll see that. We'll see that you have VM port group belonging to 100, and how we can we'll go and connect all these things. We'll see. So at the moment, just think common properties interfaces grouped inside a group, or common interfaces grouped together with the common policies and properties of the port group. I'll show you. I'll log into the VM, I'll go to the network adapter, and that network adapter I'll connect with the port group. This network adapter is nothing but virtual interface, VNIC. Alright, so we have already discussed that once you have the standard switch, at that time you have issues. What issues we have? That suppose if we have same type of port group, we have to go and create those port group in all the host. So host 1, host 2, host 3. Suppose you have HR here as a standard switch, you have to create here, everywhere. That's the problem. Means you can think like Cisco access switch. So all these VSS standard switches are working as a Cisco access switch, but again all the access switches are going to be connected with the distributed switch, and that's the term that we'll see later on, that what's the use case of the distributed switch. I have complete set of slides for that. We'll discuss inside that. But yeah, for the operational efficiency, to support new features, you need a distributed virtual switch, and inside that also you can go and attach the port groups. So port groups belonging to distributed switch we'll see later on. Alright, in this section mainly we are going to focus inside the standard switch. So how I can go and add the standard switch, I'll go and I'll show you all these steps. Now there are multiple ways to create the standard switch. First of all, we'll go to the host and see that do we have a standard switch already. If not, then we'll go and add that. This is one of the way, but we have multiple ways. I'll show you different ways to go and add the network. So you can right click to the host, you can add the network. Once you go inside that, you'll find that what you want to add: VM kernel, physical network adapter, or virtual machine port group for a standard switch. Now VM kernel, clearly you'll see here that it belongs to vMotion. So vSphere, vMotion, iSCSI, NFS, FCOE, FT, that is the fault tolerance, and virtual SAN. If you are creating the VM kernel, I'll show you all these ports, interfaces, port group, and switch, or the standard switch, in the upcoming recording. Then you may have the physical network adapter. A physical network adapter handles the network traffic to the other host on the network. Then you have the standard switch, and then we have the group for a standard switch. We'll see that. So suppose if you select the third option, then you will get the option either you want the existing standard switch or you have the new standard switch. You can go and add the adapters. So you can click on use adapter, click plus sign, then you will get the option for the physical network adapter. You can use one adapter, two adapter. Once you have one and two adapter, you can use this up and down arrow. You can set the different networking parameters or the properties of the adapters. All these things I will show you. And finally, you can see that this network having label network label, and the VLAN at the moment is untagged VLAN 0. That's it. So this way we can create the standard switch. Now suppose if you want to go and edit something, I'll go and log in and I'll show you that you can edit the vSwitch also. Obviously you select the vSwitch, you have the pencil button here for the edit. You can go and edit. So you can go and change the properties. So for example, if I go and select, it is asking about what's the MTU, what's the security policy, what's the traffic shaping, teaming, and failover. All those things we can go and select one by one. But it's still, just for knowledge purpose, we are studying that, okay, we have the standard switch option or vSwitch option, but later and in the production, generally we are using the distributed virtual switch. So this is also an option we have that we can go and check. Likewise, in the next section, in the lab section, I'll go there and I'll show you that you can go and select the physical adapter as well. And this is the way I'm going to show you. So I will go to the dashboard first. From there, from the dashboard, I will go to the ESXi. Once you go there, you have this networking option. So you can go and check the virtual switch, VM kernel adapters, physical adapters, TCP IP configuration. Once you are inside the physical adapter, here you can see you have the add network options. You can go and check all these things. I will show you one by one all these operations. Yeah. So what is the takeaway from this particular section is, the takeaway is that what is port group. You should understand what is port group irrespective of virtual switch or a distributed virtual switch. The significance of port group is there, means you are going to connect the interfaces or VNIC interfaces having common attribute properties with a same type of port group. Once you have the port group, that's the first thing that we study, the port group. Second thing we are going to study, or we have studied so far, or we have seen the slide says, how to create the standard switch. And then again, few of the slides you can see that how you can go and edit the physical adapter as well. So all these things, when we see this in a lab, then we'll understand more than these slides. But still, these slides are just for your reference, that you can go and you can do any type of change. Say for example, if I understand that what's the theory behind all these port groups and the standard switch and the distributed virtual switch, then it's actually very easy and straightforward that we can use the GUI, and inside the GUI we can go and do all sort of changes. Correct? So here it is showing that how we can go and do the load balancing in between the physical adapters, say for example active active or active standby, etc. Correct? So let's stop here, and in the next section uh, I'm going to show you the port group and a standard switch, and we'll see that how we can edit, create, even if you want we can delete also. Let us perform the lab task. So I want to make this particular video very clear, that you understand what is meaning of host, what is meaning of physical interface, what is the uh, virtual or VM interface. So suppose I have one host. In this case we have host 1 and host 2. Now here you should understand, I'll go and log in, I'll show you all those things. Now inside this host, a few of the interfaces will be physical interfaces. So I'll mark this as a physical. We'll see both the hosts, they have their individual physical interfaces. We'll see that what is the physical interfaces. And these guys, they have their vSwitch, and these guys, they have their DVS. Now DVS will be common for all the hosts, correct? And that's the use of DVS. DVS having global view for all the host and the networking, but these hosts, they may have their local switch. So VSS, say for example VS0, VS0. Now again, where we are going to use the port groups, that is also very important. So let's just understand all these things. So let me go to the host and cluster. Inside host and cluster, if I go, let me walk you all these things. So I'm inside, say, host 1, and if I go and click, say for example, you have configured. So first of all, let's start with configuration. Inside configuration, you can see you have the networking tab here. Inside networking, you have virtual switch. So what type of switch I have inside the ESXi or the host? Virtual switch, VM kernel adapter, physical adapter, and TCP/IP configuration. Now this VM kernel adapter, you think this is related to control plane traffic. Control plane traffic. This physical adapter that is going outside, this is nothing but uplink, correct? Control plane traffic, it is going outside like that. You have to think now. So you have the host, you have the control plane adapters, you have the uplink, and then you have the virtual switch where you are connecting your VM interfaces or VM NIC, or generally we are telling vNIC. We'll see, we have one diagram. We'll check that. So vNIC, virtual NICs, we are in VM, we have virtual NIC, we are connecting with the virtual switch. Now this switch, this virtual switch may be a standard switch or maybe distributed virtual switch, correct? So let me go and show you that. So I will go here and click virtual switch. Once I click that, you can see here inside virtual switch you have two category of switch. One category is this distributed virtual switch. Other category is standard switch, that is the V switch. Now on the top you have the option, you can add network and add those switches. We'll see later on. But because this particular section is focused on vSwitch, standard switch, so we'll explore on that. But suppose if I go and click this distributed switch, let me expand this. Now here you can see that this particular virtual switch is connected with different type of network interfaces. So we have the ESXi region, it's just the name, belonging to VM kernel. This is not attached with any VM. So you have different networking, and this networking interfaces, you can think these networking interfaces nothing but as a port group, correct? So here you can see that you have one of the port group that is nothing but a VM region, VDS.com. This is just the name. It attached with one of the virtual machine, that is Windows 10, correct? Now here you can see clearly that this Windows machine, this is the part of port group or the networking. They have their VNIC is connected here, that is pinned towards two uplink. Now these uplinks can do the NIC teaming, load balancing, etc. etc. So many features that we can achieve with the grouping of uplink. But this uplink that is inside one of the group, one of the networking, they are part of uplink region 01 network. So you have 1, 2, 3, 4 and 5 different type of network inside this particular distributed virtual switch, and the name of this particular distributed virtual switch is nothing but region A0 VDS comp. So before showing you this section that is the standard switch, I want to show you one very important thing. So if I go here and click networking, either you can go and click there or you can go to the menu and you have this networking. Either way is fine. So once you are inside the networking, you can see here that you have the switch. This is the DBS switch. Inside that you have the groups, correct? So inside that you can see that you have different network. This is the one way to see this. You can see distributed switch. This is actually the port group network. You have some uplink. So uplink having two hosts. This is the switch, and this particular switch is combined or can be combined with multiple hosts or the ESXi, correct? Now let's go back. We'll go to the cluster here, and inside the host, again I want to show you some other things. So suppose I'm jumping ahead of the time. Suppose in this place, if I go and click network, you can see here the network. So you can see you have the network distributed port group. You can say distributed port group. Then you have uplink port group. Then you have the standard network. We'll see this also. What does it belong to? One of the VM is part of this particular standard network. This is actually belonging to our switch, our standard switch. Then you have distributed port group, distributed port group. So you have port groups. You have uplink port group, and one VM network is there. This also I can think as a port group at the moment. It's like this. Now, before moving further, let's quickly go and check the vSwitch, because I'm very much interested in the vSwitch. So I'll go to host configuration and the vSwitch, and let's see the standard vSwitch. So now you have on a standard vSwitch, you can see one uplink and one of the VM VNIC. So one VNIC connected with one uplink. This is nothing but tiny Linux, correct? Now if you want to see more detail about this, you can go and check the MAC address adapter type. You can go and check the properties related to that. All these properties we'll discuss in the upcoming section. But yeah, what are the things you can do with the standard switch? Now you can put the security features like promiscuous MAC address changes for force transmit. By default, you can see these are the default settings. Traffic shaping option we can do. We have the NIC teaming. At the moment only one NIC is there, so we'll not do any load balancing type of thing or teaming type of thing, correct? So here you can clearly see that you think that you have your host one. Say this is my host one. Say host one. Let me write it one more time. Host one. This host having DBS, but this has a vSwitch as well. Now this vSwitch, and obviously you have the VM as well. One of the VM, that name is Tiny Linux. One of the VM port, that is nothing but VNIC, is connected with the vSwitch 0. And this vSwitch 0, you can see that they are tied with one of the uplink as well. The uplink is nothing but VMNIC2. Okay, so first of all, let's see that this particular guy, this particular host one, having how many uplinks. So if you want to see this, you have to go here to the physical adapter. You can see that it has 0, 1, 2 and 3. This 2 is connected with this particular access switch. For the moment I'll give the name as an access switch. So this is your standard switch or access switch. Here you can see. But two other NICs, say for example the physical link, say VM NIC 0 and VM NIC 1, they are connected with these DVS. So they are connected DVS, but still I have one VNIC that is called VM NIC 3 that is not assigned anywhere. So what I will do, I'll go and attach this guy here. Okay, so let's do this operation. I'll go and attach this leftover VNIC to the standard switch, and then we can do certain operations. Correct. But at the moment, I think that you are able to understand that how this local switching or how the access or the standard switch and DV is working. Correct. So here you can see you have this option of add the network, but I'll go to this switch. If I am here in the virtual switch, I can click add network. When you're adding the network, again you can see now we are going in depth. Again you can see you have option to create VM kernel network adapter that is related to control traffic such as vMotion, ISKG, NFS, FCOE, fault tolerance, vSAN and host management. Other thing, you have the virtual machine port group for a standard switch. You have the physical network adapter. Because I am focused on virtual switch, so I'll do one thing, I'll use this. Now suppose if you want to create a new standard switch, you have option here that you can use the existing. So I can go and use this guy vSwitch 0, that is my existing switch, and then I'll go next. Now the network label, I'll leave this as default. I'll leave this VLAN ID as default. I'll click next. Ready to complete, finish. Now you can see, first of all, what I have shown you here is that I simply went on and added the extra network here. So I have added, say, VM network and then VM network 2. This is nothing but a local port group. You can think this is a local port group local to this particular vSwitch. So once I have created this, then what I will do here, so now we have two port group, local port group. I can go to the tiny Linux here. If you go here, you can go here and you can click, do right click here, or you can go to the configure also. So tiny Linux and configure, I think in configure also you should get the option related to add the VM, but we are not getting it here configuration. Never mind, you have multiple ways to do the same thing. What you can do here, let me check the action also if I get, yeah, so you can do like this. You can go to the action, you can click edit setting, or you can do right click here, you can go to the edit settings, and now if you see here, browse, you can see your VM network 2 has been created. You can add this. So this is what we have done. Now let me go back to the network. First of all, now you can see that it is connected with network 2. So let me go back one more time because I want to add two network. So for that, what I can do here, that okay, I'll roll back to VM network first. This is with the local switch, and then add new device. Let me add one more network adapter, and this network adapter, this time I will add network number 2. Okay, so now what is happening, we can go and check the task as well. So we have successfully added extra network. Now when we are talking about these networks, even we'll see later on, not with the standard switch, because we are not going to do much things in the standard with respect to a standard switch. Whenever you see production network, you will find only distributed virtual switches, and those are heavily used. So I'm not stretching much inside this, but still you can see that you can go and add the standard network. So if I go down here, you can see that now inside that we have two network here. What about adding physical network adapter? So let me go and add the physical adapter as well. And so let's do this. I'll go to the physical adapter. I have one of the physical adapter that is unused. I can click this. I can click edit, and let's see, edit. I can simply change the speed and reflex, but I'll do one thing. I'll add the network physical adapter. Let's add the physical adapter now, and physical adapter with the existing switch. I have this V switch. Okay, we'll go next. I have this. Let's click if I have any unused. Yes, so I want to add this VNIC 3 there. So now you'll see initially in that vSwitch we have one uplink. Now you have added one more uplink, and here's the trick. So what you want active standby, or you want active like this. You can see all the properties, or you want to do the unused. So for example, I want active. Then you can see you have all sort of properties here, CDP, LLDP, all these options we have. We'll check this later on, but I can go next here, finish. So once I finish this, now you can see these two physical interfaces part of vSwitch. I'll go quickly back to the switch, and inside the switch you can see now you have two. You can see. So clearly you see that how I have added the VNIC virtual NIC, and then added one interface inside the VM machine, and both the interfaces you can see here, they are part of the NIC or the port group, and then the port group related to physical interface, but it's the physical interface. Use as active. You have option, you can use this as a active standby as well. You can go and check the settings. So I hope you understand how we can do the operations related to networking. Now on the top you can see manage physical adapters, add the networking. So from here also you have the option. So multiple options you have when you are adding the VM kernel for this particular switch. So that option also you have. Okay, existing standard switch, if you are adding the VM kernel name, what is the IPv4 address, what's the use of this, it's the vMotion or whatever is the management interface, obtain IPv4 address automatically, or you have any address that you want to put, you have any subnet mask you want to put, you have the default gateway and all. I'm just showing it for an example. So enter a valid subnet mask. So I'll do one thing, I'll give 24. We'll do this thing, we'll use this notation, but it is not telling you that in which format you have to put, etc. And finish. This will fail because this is the wrong address and all, but let's see what error we are getting. So we can go and check the alarm and events as well, that what errors we are getting adding this particular VM kernel NIC. Occurred during host configuration, and we have error because that IP is not existing and the other stuff. But I'm just showing you that from here also you can add, if you want to edit anything you can go and do the edit. So with respect to vSwitch, I can go and change the properties, I can go and change the security setting like MAC address changes, force transmit. We'll see all these things later on, what does mean, what is the overall, so for example, the use of this and the definition of this we'll see in the upcoming slides. Load balancing method, you can see you have plenty of load balancing method like IP-based, MAC-based, virtual port, etc. Fallback, notify, and the failover order. Then if you want to click manage, you can do up and down. So this is actually all the operations related to local switch. And this actually we are not using much, but it's good that we understand that how we can add, delete, change, modify, etc., etc. So how we are doing n number of operations related to this. But our more focus will be on the distributed virtual switch. So let's stop here, and upcoming section will again learn more about the virtual networking. Let us discuss the port group properties. Here you can see that we have the properties, security, traffic shaping, and the teaming and the failover option. When we are inside security, we have promiscuous mode, MAC address change, and the force transmit. And the order that we can select, or the options that to select, is accept or reject, correct? So let's see one by one. In case of promiscuous mode, if it is chosen as a reject, that means there is no effect. But if you accept this mode, that means you are detecting the frames with respect to whatever policy you have configured for that particular port group, or for that particular adapter inside the port group, correct? So if it is accept, that means you are detecting all the frames passing through the vSphere standard switch. You can see the default setting here. The default will be like this: promiscuous is reject, MAC address change, and the force transmit is accept. So let's see what is there in the MAC address changes. In MAC address change, one thing to note here, that the vSphere, that is inside the VMX configuration file where they are storing the MAC address. So suppose if they see that any change inside the MAC address, means if you make this as a reject, if any change in the MAC address, they will start dropping the traffic. Rather, if you make this as a accept, that means in that case they will allow those frames. So what is happening here? Changing the MAC address from the guest OS has the intended effect. Frames sent to the altered MAC address are received by the virtual machine. So even the MAC address change is there, the frames will be passed. Force transmit, reject means, again force means someone is doing some sort of spoofing in case of MAC address. So here what will happen, and this is again applied to the outbound frame. So any outbound frame with a source MAC address that is different from the one currently set in the adapter is dropped. So if while doing the transmission of the frames, it will see what's the source MAC address, what is set in the adapter, and if it is reject, it will drop that. If it is accept, it will allow that. So it depends that what security policies we have. According to that, we can accept or reject. Alright, traffic shaping, it's very much like Cisco configuration, Cisco traffic shaping, or the QoS configurations. What is happening here, that you have say average bandwidth, then you may have certain peak bandwidth, so say peak, and then if you are going or for some slice of time, if you are going little bit up, then you have burst traffic. Okay, so these are the normal actually option inside the Cisco QoS as well. What is the standard, what is the peak bandwidth, and how much you want to buffer in case of the burst. Okay, all right. Then we have the important thing, that is the load balancing option and the failover in case of teaming. So here you can see that we have multiple options. I think we have 6 load balancing options here. So let us see all those load balancing options one by one. So first load balancing option, here you can see that route based on the originating virtual port. Now what will happen, that the select an uplink based on the virtual port ID on the switch. So once they select the uplink, then they will stick some sort of pinning type of option. You have 2 or 3 uplink, You select one of the uplink and you are sticking with that. That's the default load balancing option we have. Then we have the route based IP hash and the MAC based IP hash. This is very much like if you are comparing this with the LACP port channel. In switch, when we are creating the ether channel, so at that time they can do route based, they can do uh, sorry, they can do IP MAC based, they can do IP MAC port address based. Means there are also so many load balancing methods in case of LACP and PAGP, that is the Cisco Ether channel term. There are here also you can see that you have a route based IP hash, means you are checking the hash value of the source and the destination IP, and then you are sending the frames over the uplink. Then same thing with respect to MAC also we have. Then we have the load balancing option with respect to NIC load. So suppose if we have two NIC, one of the NIC having load 30%, one have 10%, automatically load will shift to the other NIC. So this is also a nice feature. Then we have explicit failover order, means according to the high interface number, suppose this is number 2, this is number 1, you are always pinned to number 2. So what is happening? Let me read. From the list of active adapters, always use the highest order uplink that passes the failover detection criteria. And this is no actual load balancing is performed in this option. Obviously, this is something like user defined. You can go and define the load balancing method. So once we have the load balancing methods, then what options we have? Rest of the options you can see we have the network failure detection, link status only or beacon related. Then you have notify switch and fallback. Link status means it's very flat. If link is up and down, it will tell us, oh, this particular link you are sending the traffic is down, use the other link. Then you have the beacon probing. This is a smart, intelligent way to detect the link status. So 1, 2, 3, whatever number of links we have, we are sending the probes after every 1 second, and we are checking that okay, link is up or not. And then if it is not up, obviously the traffic will go to the some other direction. Very much like we are doing in Cisco also, but generally we try to check the ISP link. So we have some sort of IP tracking SLA type of thing in Cisco. So you're checking one link up to with respect to other link, sending some sort of IP, ICMP, unreachable type of beacon or probes, and you're checking that link is up or not. If it is not, if it is unreachable, after every 1 second you're sending the probes with, say for example, hold down timer of 3 seconds or 5 seconds. If it is not responding, you can go to the other direction. Notify switch. We have this option, specify where the virtual switch notify the physical switch in case of failover. So if any failover, it will notify the switch. And then finally, you have this failover option. This is also very logical. Failover option, you have the fallback is set to yes if fallback is set to no. So suppose if you have two link and fallback is set to yes, suppose this link is down, this will become active. Suppose if this link will come back, this will become active standby in case of active standby. So whatever original state of the link was there, once it will get recovered, it will start forwarding the traffic. And that is not the case in the if the fallback is set to no. So what will happen, that two links are there, active standby, this is gone, this standby become active, or maybe active. So now he is the primary who is sending the traffic. Now suppose if this link will get restored, still it will sending the traffic until unless something will happen here, and then it will become active and sending the traffic. So these are the failover fallback options we have, and these are all the options we have inside the vSwitch. You can see still we have multiple options related to security, traffic shaping, teaming, and failover. This recording session is going to be very small. We are going to understand about a distributed virtual switch. And now suppose if you see this diagram, now this diagram is a little bit confusing, but let's come back to this diagram after this. So now if you see this particular diagram, you can see that the distributed virtual switch having host wide visibility. So all the hosts, they can connect with the distributed virtual switch, although these hosts, they have their own standard switch. This particular own standard switch, you can see that they have a VM kernel NIC, they have uplink, these are nothing but a physical link, you can think VM NIC as a uplink, and they have a VNIC, that is VM hosted NIC. So if I draw this diagram, you can understand, say you have guest operating system. This is nothing but the guest OS and hosted over the host. So you may have multiple guests. All these multiple guests, they may be part of this vSwitch. Here you can see, just for an example, it is shown like this, and they may be part of DBS. But what is interesting and important to note here is that you have VM kernel NIC, you have VM NIC, you have VNIC. So you have three different type of NIC. You have NIC for management, you have NIC for uplink, you have NIC for virtual machine, correct? And the difference here is that this distributed virtual switch has a global visibility. So it will be visible for all the hosts. Now here you can understand this diagram now. So let me change the color of my pen. Now here you can see that you have the physical interfaces here. Now these physical interfaces are nothing but VM NIC. So you have VM NIC 1, VM NIC 2. Here you have VM NIC 1 for this, VM NIC 2 for this particular host. Like that you can think. And you can see the uplink. Now you have the VM. So this particular VM, what is the name? This is nothing but VNIC. So they are VNIC, they are VNIC, VNIC, VNIC. So they are VNIC, they are VNIC. Now you have the distributed virtual switch. Here we have the port group A, B, C, D, etc. Now in the diagram you can clearly see, suppose this A belong to HR. A is a placeholder for HR. So these two VMs, they are belonging to HR group. So these two guest operating system, they are, for example, HR server 1 or HR server 2. Okay, or generally we are giving this name like web server 1, web server 2. Okay, then you can see that you have VM, and here it's showing like this, but you have VM with multiple VNIC. So here I have VM with two VNIC. They are part of, for example, this is app server 01. Then you can see the other host inside the cluster. So there may be, all these hosts are part of DC cluster 01. So other side, that VM, they have their VNIC. This guy having the VNIC, they are part of one of the other port group, that is nothing but DB. So this VM name is, say, DB, I'll write DB server 01. This is DB server 02. So now you can understand that you can group all those different VMs as per their attributes to the same type of port groups, and then you can apply certain rules, certain policies over the distributed virtual switch inside the port groups, and those will be applicable to all these endpoints or all these VMs. So here you can see the endpoint is nothing but your virtual machine. So either the traffic is going to east to west, or traffic is going from south to north or north to south, but when it is going outside, it is leaving the cluster, or when it is leaving the vSphere, at that time they are using the physical interfaces. So this is actually the important analogy, and I hope that you understand that. You please pause the recording and then you can check these definition. Whatever we have discussed so far, you'll find the same thing written here. Let us do the walkthrough of the distributed virtual switch. So we have one distributed virtual switch. I can go here, I can show you that what's the summary, how to do the configuration inside this distributed virtual switch. So I can go here, I can select configuration, and then we can check the properties. Now here you can see clearly that you have properties related to general properties, advanced, discovery protocol, some sort of administrator contract or contact, sorry. These are the properties we have. I'll log into the switch and I'll show you all these options. Then you can go and view the topology. You can create the private VLAN. You can do the configuration related to net flow, port mirroring. You can go and do the configuration related to health check. So I'll show you all these options one by one. Suppose if you want to set some of the properties. So what you can do here, you can click to the configuration and then you can go to the properties. You can click edit. Once you click edit, then you will get the option general and advanced. In general, you can go change the name, you can go and change the total number of uplink ports, your IO control, you can make it disable, enable, you can put the description, correct? Then what is the meaning of uplink? You can add more number of uplink, you can add more number of ports, you can give this enable or disable for the IO control, you can put the description. Then suppose if you go inside the advanced option, here you can see the options related to MTU, multicast filter mode, discovery protocol, administration contract. Now MTU we can go increase or decrease, means depending upon the use case. But in multicast filter mode, you can see that you have two mode, basic and IGMP MLD snooping. Basic means from the IPv4 address, it will make out uh, what is the MAC address, and then it will forward the traffic. In case of IGMP or MLD snooping, as per their IGMP membership, they will forward the traffic. Discovery protocol, we have two options, CDP, LLDP, and disable also. So suppose if you are using CDP, Cisco Discovery Protocol, you can see here the CDP, LLDP, and disable as well. So if you are using CDP, you have option that you are the listener, or you are advertising, or you are listening and advertising both. We can go to the health check, and again we can click edit. Once you click edit, then you get the option related to VLAN and MTU. What is the state? What's the interval? These intervals are in minute. The teaming failover, what's the state? What's the interval? If you want, you can change those values, correct? So what I'm going to do before moving further, let me go log into the vSphere client, and I'll show you all these options where we'll find. All right, so I logged in inside the vSphere client. What I can do, you have option. You can go to the menu. You can go and select the networking. From here also you can see the networking. So let's go and go inside the networking. Inside network, I want to check this switch. Inside switch summary, you can see that switch detail. So how many network you have? This is nothing but your port group. How many hosts you have, how many virtual machines are connected, how many ports are there. Then if you have any nodes, then if you have any tag, what features you have, we'll go and see all the features. So IO feature, net flow, you can see all these features are supported. Net flow supported, LLTP supported, link aggregation control protocol, that is basic support, port mirroring supported, IGMP MLD snooping supported, health check supported, and then you have the custom attribute. So how you can go and configure this, go and click to the configure. We are inside the setting and properties. If I go click edit, here you can see that I can go and change the name. I can change the number of uplink ports. I'll leave this as 4. Then you have the IO control. You can enable, disable. If you want to put any description, you can put the description. Then we can go to this advanced option. We have the MTU option. Here you can see the multicast option, either the basic or IGMP MLD. Then the discovery protocol, we have option LLDP, CDP, disable. Then the operation, what operation you want. You want listen, advertise, both. We can go and give the administrator contract name and the other details. Apart from that, you can see inside the setting, I can go and check the topology. This thing actually we have checked earlier. So earlier, previously we went here and we have done the walkthrough. We have seen the port groups and the VM. Basically, they are nothing but vNIC and VM kernel interfaces, and these are nothing but the uplink interfaces that's belonging to the physical interface. So you have the topology. Then if you want to create the private VLAN, like in Cisco, we have private VLAN type. So for example, a community, isolated, promiscuous, etc. So I can go and create VLAN inside VLAN that will work as a second. Here clearly you can see primary VLAN, secondary VLAN, VLAN type. So we can go click edit and we can define that. What's the primary VLAN you want to add? What's the secondary VLAN you want to add, etc., etc. Correct? And you can see the type is by default promiscuous, but here you have options. So let's see that the options that we have, it is creating. So once I click here plus, you can see I can go and change the number, say for example 30, and this is the secondary VLAN. What's the VLAN type you have? So if you click here, by default it is taking promiscuous, but I'll not go deep inside this. I will leave this at the moment as it is. So I have primary VLAN, I have secondary VLAN. You can see primary VLAN, secondary VLAN, both are 3030 like that. Then we have the NetFlow, very much similar to the Cisco configuration of NetFlow, who is the collector IP, collector port, what's the domain, switch IP address, and then you have the collector sampling, inactive or active timers, etc. Then we can do the mirroring. This is nothing but the span or ER span like in Cisco we have. So if I go and check the options, you can see clearly here that you have the port, distributed port mirroring, remote mirroring source, remote mirroring destination, encapsulated remote mirroring source. So we have all those options related to port mirroring. Finally, you can go and check the health alarm. So VLAN and MTU, teaming and failover. So I can go and check this health check, the state for VLAN and MTU. You can go and enable. This is for 1 minute teaming failover state. You can go and enable, you can click OK. This is the setting that we can go and do inside the vSwitch. Later on we'll add the rest of the things as well, but you can go log into the vSwitch, you can go and check most of the features, and here you can see the difference now with the standard switch and the distributed switch. In the distributed switch you have so many added features. So you have private VLAN, you have NetFlow, you have mirroring, health check, etc. So that's why this distributed virtual switch is actually important and popular in the production network. Now we are going to learn that how to create the distributed port group. It's actually very easy. I can go to the distributed virtual switch, right click, and then I can create this distributed port group. So I have that option. I can go and give any name. I will give any logical name. Then we have the configuration setting. What's the port binding option? It is static or femoral. What's the port allocation option? Is it elastic or fixed? Then number of ports, then the resource pool, VLAN, some advanced option. So what does it mean by port binding? Here you can see the first option is port binding. Either we can use a static, so statically the VM interfaces or vNIC I can go and attach with the distributed port group, or there is no binding, that is the femoral port. Then in the port allocation you can see you have the elastic option, you have fixed option. Elastic means that is the default option. By default you have 8 port assigned. If that 8 port will get assigned, it will create again 8 ports. Fixed means the default number of ports is set to 8. No additional ports are created when all the port will get assigned or exhausted. The number of ports, we can go and give the number of ports. Then we have the option related to network resource pool. Why we are using this network resource pool? If you have created a network pool to help control traffic, you can select this. Just for the control traffic, we have this option. Then in bottom, you can see you have the VLAN type. So VLAN type may be none, uh, trunking, private VLAN, etc. So whatever option we have over the interface to the VLAN, we can go and assign it, very much similar to Cisco interfaces where we have switchboard mode, access, trunk, and add some uh, VLAN over the trunk, etc. Then we have the private VLAN option also in the switch interfaces. So we have all those options. Then finally, you have the advanced option. Select this checkbox to customize the policy configuration for the new distributed port group. So if you want to customize, I can go here and use the advanced option. Here you can see advanced, check this, customize default policies configuration. So like that, we'll go and create the port group. Once you create that, you can go and check inside the VM networking. This new port group will be created. Now next, what we can do, we'll go to the topology section and we'll see that where exactly this port group is. You can go and check that port group. And not only you can check the port group, but what I will do in the activity that um, some of the VM with the VNIC I will assign with this particular port group, and then we can see that the VNIC, how they are mapped with the VM NIC or the uplink. Correct. So those things we can go and see. Also here you can see in the diagram that you have the VM kernel ports. You have the VM kernel port with the different port groups as well. All right, here you can see this tiny URL is the VNIC is mapped with the VM NIC. So let's log into the vSphere client and let's complete this task. All right, so I logged in inside the vSphere client and we are inside the VM network. We are inside the network option. So here you have the network. Here you can see that you have the distributed virtual switch. Simply go and do the right click. You can create the distributed port group. Yes, I want to create the port group, although I have option to import the port group, manage the distributed port group. So I don't want that. I can give the name, say I'm going to use this as a, say for example, I give name as a tiny web server group. Okay, location is this particular switch. That's okay. We'll go next. Then you can see the option. You have the port binding, static or ephemeral, that is no binding. So static and binding, you have elastic and fixed option. By default you have the 8. After that it will go and add. Network resource pool for network control traffic, we'll leave it. VLAN type, I'll leave it as a none, but you have the VLAN trunking, and the private VLAN option. Customize default policy configuration. If you enable, then you can see that you have traffic shaping, teaming failover, monitoring, miscellaneous. All those customization option will get appeared. So I'll make this on, so we'll understand, we'll see all those options as well. We have already discussed about promiscuous MAC address and the force transmit. And let me go back. All is reject, reject, reject. I'll make this as a accept for the moment, as we have checked in our last section. Then the traffic shaping, at the moment I'll leave this as it is. Then you can see that you have 4 uplink, all are active. The default is route based on the originating virtual port. That's the load balancing default method. Then you have the network failure, link status. You have probe also. We have study about this. Notify switch, yes. Fallback, yes. So it will restore the original status of the interface if it will get fallbacked. Then monitoring, I will not use NetFlow at the moment, but if you want, you can go enable and then you can use it. At the moment, I'll make this as a disable. Then you have the miscellaneous option. Inside miscellaneous, block all ports. Option is yes or no. We'll leave this. Next. So now you have your distributed port group with all those options, and now here you can see that you have tiny web server. This is attached with two hosts, that is two hypervisors. Network protocol profile is not there. Rest of the things are not there at the moment. So here you can see that it is attached with two hosts, but suppose if you want to attach the host here, we'll see that. I'll show you that how to do some sort of manipulation later on. At the moment, what I want to show at this point of time is that once you create the distributed port group, first of all, I want to go to this switch and I want to show you, let me go and show you the changes that happens. So if I go here, now I can see this that the network is 6. So 1, 2, 3, 4, 5, 6. 5 plus 1, initially it was 5. Rest of the things will leave this as same at the moment. I can go to the configuration. Inside the configuration, I want to show you this topology option. Once you are inside the topology, if I scroll down here, you can see here. So you have this tiny web server group as per the alphabetical order they have taken. So E, S, and then T, and then V. So now what I want to show here is the few of the port groups. So for example, this particular port group, that is VM regional A0 VDS comp, having two virtual machine, tiny and the Windows, and now they are mapped. So they are mapped from here up to this point, correct? If you want to see the setting, you can see it. So what I want to do here, that I want to remove this tiny and I want to attach this tiny here. So you can see that the number of virtual machines will increase, correct? So that will be the valid test. What I can do here, multiple ways we have. I can go to the host cluster or maybe VM and templates, because I'm looking for the tiny Linux and the two, both I am looking for. So what I can do here, I can go to the edit setting. That's the easiest way to reach there. I can go to the network controller. I can browse this, and now you can associate with the tiny web server. Remember, port group is the same type of attributes, same type of properties that you are connecting your endpoint or the virtual machine interface to this particular group, correct? So I have done this. Once we've done this, then I'll click OK. Then I'll go to this tiny 2 as well, and there also we'll go to the edit setting. Once we are here, instead of VM network, click browse, and then I'll go and use this tiny web server group. Okay. Then we'll go back to the networking and we'll go to the switch, configure, and topology. We are already inside the topology. Now you can see this tiny URL. Two are connected, correct? To VNIC, going to this particular uplink, and if you want to see this uplink and the associated host, so this host has these two uplinks, this host has these two uplinks, VMNIC 0001, like 0, 0 and 1, VMNIC 0 and 1, both the hosts having those. So like that, you can see that it is mapped. Few of the uplinks, 3 and 4, they are unused. Few of the uplinks are in use. So this is the way you can create the port group. Once you have the port group, how you can go and attach the VM interface with the port group, and if you want, you can go and verify from this particular configuration and topology option. Alright, so I hope you understand up to this point. Let's stop here. Next section we'll do more lab related to this.